Hello and welcome to this video course on AZ-900 Microsoft Azure Fundamentals. I'm so glad to see that you're here taking advantage of this video training for the AZ-900 Microsoft Azure Fundamentals exam. Anyone who needs to have a foundational understanding of cloud services and cloud-based solutions with Microsoft Azure can benefit from this video course. Whether you are preparing for the AZ-900 exam now, just starting to work with the cloud, or need to understand terminology and concepts related to the cloud, this video will help you move forward in your career. Let me give you a quick introduction to what we'll cover in this video. All these topics are covered in the same order and breakdown that Microsoft uses in the exam outline, so keep that in mind. We'll start off with some high-level cloud concepts and an overview of the different cloud models. We'll define exactly what cloud computing is, and we'll introduce the private cloud, the public cloud, and hybrid cloud scenarios. We'll also talk about cloud concepts like high availability and scalability, agility, and other terms you need to understand. We'll introduce security and governance concepts as we lay the framework for deeper coverage of these topics later on in the course. We'll talk about manageability of your cloud resources, and we'll wrap up with a discussion of the different cloud service types and how benefits and drawbacks each offer you. Next, we'll start with a discussion of some of the core architectural components of Azure. You'll learn about Azure regions and data centers, and we'll talk about some high-level concepts that help you manage Azure resources. Next, we'll dig into Azure compute and networking services, including virtual machines and Azure virtual networks. We'll talk about the different Azure storage services that are available, and we'll cover some of the concepts that tie these storage services into the cloud concepts of redundancy and high availability. We'll wrap up with identity, access, and security concepts. We'll talk about some general security concepts, and we'll tie these into Azure with a discussion of Azure Active Directory, Azure Role-Based Access Control, Microsoft Defender for Cloud, and much more. Finally, we'll cover management and governance of your resources. We'll talk about costs in Azure, the things that can impact your costs, and how you can predict and control your costs in the cloud. We'll talk about the different options you have for creating and managing Azure resources, including the command line tools offered in Azure. And we'll talk about how you can extend Azure features into your on-premises environment and into other clouds using Azure Arc. We'll close out the course with a thorough examination of the monitoring tools available in Azure, including Azure Monitor. My goal in this course is for you to come away with a solid understanding of the core concepts that will help you as you head into the Azure Fundamentals exam. Along the way, I hope you have some fun learning all about Azure. All right, enough with the introduction. Let's dive right in. Welcome to Describe Cloud Concepts. Here you'll be introduced to cloud computing and some of the key concepts that set the framework for the rest of the course. We'll talk about cloud computing in general, including the different cloud models and when you might want to choose one over another. We'll also talk about the benefits of using cloud services, and we'll cover core concepts such as high availability, scalability, reliability, and predictability. We'll close out with a discussion of the 3 different cloud service types, along with some information about why you might choose one over the other. Before we go too far into more in-depth cloud concepts, we should start with understanding just what cloud computing is. Here we'll describe cloud computing and some of the benefits it brings. In this lesson, we start with a definition of cloud computing, and we carry that forward into a discussion of the shared responsibility model in the cloud, a concept that will make appearances throughout the rest of this course. We also talk about the public cloud, the private cloud, and the hybrid cloud. These are 3 cloud models, and we explore the benefits and drawbacks of each one. You then learn about how the cloud offers a consumption-based model and how you can best take advantage of that benefit. Let's take a minute to talk about cloud computing. What exactly is cloud computing? If I have this one computer, is that cloud computing? I don't think so. But what if I have a lot of computers? And what if those computers are all connected to the internet? Is that cloud computing? It could be, but this alone doesn't accurately describe cloud computing. And while network connectivity is certainly part of cloud computing, as you'll soon see, that network doesn't have to be the internet. It's actually harder to define cloud computing than you might think. We've kind of met the base requirements with our example computers shown here that are connected to a network, but there are many other components that make up cloud computing. And as we progress through this module, you'll learn all about these cloud concepts. And ultimately, it's all of these concepts together that define cloud computing. Let's begin our discussion of these cloud concepts with the shared responsibility model. This is a key concept in cloud computing, and what it really means is that you and the cloud provider share the responsibility for the apps that you run in the cloud. Now, how much of that responsibility relies on you versus the cloud provider depends on the choices you make when you deploy to the cloud. But it's important to note that the cloud provider almost never takes responsibility for everything. At least part of the responsibility for your app performing the way you want it to will be yours. And there's another important point here. Cloud providers will only take responsibility for things that are within their control. So for example, if you deploy a website to the cloud and it has software bugs that impact that app in a negative way, the cloud provider will never take responsibility for that because it's not entirely within their control. As I said earlier, there are decisions you can make that impact the amount of responsibility that you have in the cloud. And you'll learn more about those concepts as we progress further through this module. There are 3 different cloud models that are available to you, and each one of them has its own unique benefits and drawbacks. So let's explore these cloud models in detail so that you can make better decisions about which is right for you. So first, the public cloud, which is shared infrastructure, things like networks, computers, and so forth, that are provided by a cloud provider. The public cloud is often referred to as a multi-tenant environment because multiple companies and people are all using the same underlying infrastructure. There are several benefits associated with a public cloud. The first is agility, meaning that you can easily add resources when you need them and reduce the number of resources when you don't. In fact, the public cloud often provides features that make agility an automatic thing, so you don't even have to think about it. The public cloud also offers quick deployment to the cloud, and that's especially important if you want to deploy maybe an existing app from on-premises or from another cloud provider. Naturally, cloud providers want to make adopting their services as easy as possible, and offering quick and easy deployment features is one way they do that. The public cloud also provides easy management of cloud applications, and as you'll learn in Lesson 3, how easy management is differs depending on which type of service you use. But cloud providers in the public cloud are always going to offer some features to make management of your cloud services as easy as possible. Finally, the public cloud allows you to control costs. You usually only pay for what you use in the cloud, and we'll cover more of that in the next part of this lesson. And the cloud provider gives you powerful tools that enable you to track costs and to prevent unwanted charges. And we'll go into a lot more detail about costs when we get to Lesson 8. Now, while you do have a lot of benefits in the public cloud, there are also some drawbacks. In the public cloud, you do lose some control. You don't have visibility into the entire infrastructure. So you have to rely on the cloud provider for many things that might otherwise be within your control. If you have specific security and regulatory requirements, you might find some challenges in the public cloud. Cloud providers do recognize that security and regulatory requirements are important, and they do take steps to address that. But depending on how strict your requirements are, you might find the public cloud to not be your best choice. You also lose some flexibility in the public cloud. Cloud providers give you cloud offerings that are configured a certain way, and you're often locked into choosing one of those pre-configured choices rather than choosing everything yourself. And lastly, the public cloud is made up of shared infrastructure, like I was talking about before. And depending on your requirements, that might be a drawback for you, especially if you have security and privacy needs that require your data not be on shared systems. Another cloud model is the private cloud. A private cloud is dedicated to a single company, and for that reason it's sometimes referred to as a single-tenant cloud. Like the public cloud, the private cloud offers several benefits. Just like the public cloud, the private cloud provides agility with all the same benefits that we discussed when we were going over the public cloud model. But unlike the public cloud model, the private cloud offers a private network that's dedicated to your company. And that means you don't share any network infrastructure with anyone else. That can be important for many companies that rely on privacy. The private cloud can also be used without access to the internet. Now, why would you want to do that? Well, think about a cruise ship that makes trips across the oceans where internet access may not be reliable. They still want to manage their systems with all the benefits of the cloud, but they need to do it without access to the internet. The private cloud is a great choice for this because they can operate in a disconnected way and then sync their systems with the infrastructure that exists across that private cloud when they get back online. The private cloud can also help you control costs because you own everything and don't have to pay any fees or costs that are incurred in the public cloud. However, in the private cloud, costs can be a double-edged sword. Let's look at some of the drawbacks of the private cloud, and I'll explain what that means. You can utilize the private cloud by paying a private cloud provider to supply the infrastructure to you. Now, that infrastructure is still dedicated only to you, but it's owned by a third-party provider, and they incur the cost of IT staff and power and things like that. However, you can also buy the infrastructure yourself, and if you go that route, costs can be high because you have to pay for the infrastructure up front, and you need IT staff to manage it and all of those things. Like many things related to the cloud, you have to weigh the pros and cons for any particular approach and then decide what's best for you. In the private cloud, you also might not be able to effectively control access to data if you pay a third-party provider. Even though the infrastructure is dedicated to you, the third-party provider will own and manage the systems on which the data lives. And that could be a concern for you. Now, to alleviate that, you'd need to own the infrastructure yourself, thereby increasing your costs and your management efforts. The choice of a single cloud computing model could be a difficult one. It may very well be the case that a single model just does not meet your needs. And for that reason, there's a third cloud model called the hybrid cloud. Now, as you might have guessed, the hybrid cloud is a mix of public and private cloud models. One of the benefits of the hybrid cloud model is that you keep some systems on premises. For example, if you have a secure database system, let's say, that your cloud application needs to use, you can keep that database system on premises and then use networking features of the cloud to connect it to your cloud resources. Now, we'll talk about some of those networking features when we get to Lesson 5. The hybrid cloud also offers support for legacy systems. You might have some older systems on premises that aren't compatible with modern systems in the cloud. And by using the hybrid cloud, you can continue to use those legacy systems with your cloud applications. The hybrid cloud also allows you to maintain control over your data and infrastructure when needed for all of those reasons that we've already talked about. Now, just as with the other cloud models, the hybrid cloud also has a few drawbacks. As I said, you can connect your on-premises systems to your cloud applications using networking features, but doing that can be technically complex, not only to set up in the first place, but also to troubleshoot if something goes wrong. You might also have to deal with data compatibility issues, especially if you're using maybe an older database technology on premises. And finally, the hybrid cloud will require that you have some IT expertise within your company to manage the on-premises resources and those connectivity requirements to your cloud applications. Choosing the right cloud model can be a challenge. The best approach is to list your requirements related to ease of management, privacy, security, and so on. And once you do that, you'll be in a better position to weigh the pros and cons of each model and settle on your best choice. Before we move to the next lesson and talk about some of the benefits of using the cloud, let's wrap up with a discussion of the consumption-based model in the cloud. Now, when I say consumption-based model, what that means is that you pay only for those resources that are allocated to you. Now, the use of the word allocated is important because you can have a cloud resource that's allocated to you even though you aren't actually using that resource. In the cloud, if something's allocated to you, you're consuming it even if you aren't actively using it. So for example, if you have a virtual machine running in the cloud, you're consuming that virtual machine even if you aren't actually using it, and that means you're going to be charged for it. Now, this distinction is important, and because of this distinction, there are a couple of rules that you can follow to help you control costs in a consumption-based model. First of all, don't allocate more resources than you need. That seems pretty obvious. And it doesn't just apply to the number of resources. It also applies to the level of resources. So for example, don't allocate a virtual machine with an 8-core processor if you only need one with 2 cores, because you're going to pay more for a machine that has more cores. Another rule is that you should ensure you fully utilize the resources you allocate. Don't let resources sit unused, because that means you're paying for something you aren't actually getting any benefit from. There are many features of the cloud that can help you follow these rules, and we'll look at some of them in the next lesson. But for now, if you follow these rules, you'll experience the true benefit of a consumption-based model in the cloud. There are plenty of benefits to moving to the cloud. After all, that's why more and more companies are moving to the cloud every day. Let's talk about some of those benefits. We talk about high availability and scalability, two related concepts that are huge benefits of the cloud. Then we tie those concepts into the concepts of reliability and predictability. We also talk about security in the cloud, and we introduce the concept of governance in the cloud. We end the lesson with how the cloud helps with manageability. Let's begin our discussion of the benefits of using the cloud by talking about the concept of availability. Now, what exactly is meant by availability? Well, availability means that an application and the systems that it uses are accessible by users. That's it. So with that said, what is it that can impact the availability of an application? What can make an application unavailable? Well, it could be a network outage. That could mean a wide-scale network outage, such as a problem at maybe an internet service provider, or it could be a smaller scale, such as a problem with network hardware. Another problem that could impact availability is an application failure, whether that's because of a bug in the application or a misconfigured application, or any one of numerous other application problems. It could be a system outage, such as a failure in a VM that the application needs to use. Availability can be impacted by a power outage. And just like the network outage scenario, this could be a localized outage or a wider scale problem. Another impact to availability might be a problem with a reliant system, such as maybe a database server. Now, these are only some of the things that can impact availability, but I think you get the point. One of the benefits of the cloud is that it offers high availability. And high availability is normally considered to be an availability level of 99% or higher. The cloud offers this level of availability because there are systems that are in place to account for the reasons above that might impact availability. But as I pointed out in lesson 1, a cloud provider is only responsible for those things that are within their control. So you have to keep that in mind. Another benefit of the cloud is scalability. And when we talk about scalability, we're referring to a couple of different things. The first is vertical scaling. And this is when you scale from a less powerful machine to a more powerful machine, or a less powerful service to a more powerful service. Maybe that means scaling from a VM with 1 core to 2 cores, or a VM with 8 gigabytes of memory to a VM with 16 gigabytes of memory. This is commonly referred to as scaling up, but notice here that the arrow is a two-way arrow. So in addition to scaling up, you can also scale down to a less powerful machine. The ability to do this relates to the concept of the consumption-based model that we talked about before. I mean, sure, if you need a more powerful machine, scale up to one. But when your needs go back down and you no longer need that powerful machine, scale back down so you don't have to pay for more than you need. Now, the other type of scalability is horizontal scaling, and this is often referred to as scaling out. This is when you scale to more instances of a resource like a virtual machine. So, for example, you might scale from 1 virtual machine to 4 virtual machines like I've shown here. Now, when you scale out like this, you'd have 4 virtual machines that are exactly the same. Same configuration, same power. They'd all be running the exact same applications. And when you do this, you'll also want to have some kind of component that can distribute the load across these machines. Now, just like when scaling up, when you scale out, you can also scale back when you no longer need that additional capability. The cloud makes this scaling in both directions easy. And that's what we mean when we say that the cloud offers agility and the ability to easily scale up and down or out and back is referred to as elasticity. You can think of it as kind of like a rubber band that stretches in one direction and then easily returns to its original shape. So now you've learned about availability and scalability. Let's look at a couple of concepts related to reliability and predictability. And the first is fault tolerance. Now, a fault occurs when a failure happens. What kind of failure? It could actually be a lot of things. And all of the things we talked about when we covered high availability could be considered faults: a networking problem, a power outage, a hardware failure, so on. Fault tolerance means that you can tolerate a fault. It means that even if a fault happens, you still maintain availability. Now, the cloud offers many features that provide fault tolerance, and we'll cover some of those throughout this course. A fault usually refers to something that causes a problem on a smaller scale, but there's another kind of problem that can impact availability, and that's a disaster. A disaster is a large-scale event, and it's more impactful than a fault. A disaster can be a natural event, such as maybe like a large storm, like a hurricane, or a large forest fire, or a large-scale flood. The way you prepare for such a large-scale event differs from how you might approach preparing for a possible fault. But the primary point is that you should definitely plan for disasters. A disaster plan is often referred to as a business continuity and disaster recovery plan, or BCDR. And cloud providers usually make information and tools available to you that can help you to come up with a good BCDR plan. There are a couple of other benefits to the cloud that we're going to cover, and they're in the area of security and governance. Security refers to restricting access to your resources to only those people that you allow. And governance refers to the level of access someone has once they do have access. And it also includes what they can do with that access and how they can do it. You might have governance in place to comply with certain governmental or industry regulations and standards, but you likely will also have governance related to your own company. Governance can definitely help you to save money and to get the most advantage of the consumption-based model. Cloud providers can help you with security and governance, and some of that assistance is in the form of documentation, so you can properly configure those things that are in your realm of responsibility to be secure and to provide the proper level of governance. However, cloud providers also offer services and features that can help you identify security and governance concerns and correct them easily, often before they end up impacting you. And Azure gives you features that make applying governance easy, regardless of the reason you need that governance to be in place, whether it's because of a regulation or maybe a business rule that's in place in your company. We'll talk about these in the context of Azure when we get to modules 2 and 3. In lesson 1, I talked about the fact that cloud providers can make it easy to manage your cloud resources. So let's dig a little more into manageability and the cloud. Deploying to the cloud definitely is not a click it and forget it kind of thing. Once you deploy something to the cloud, you'll want to keep an eye on it and make sure everything's running as it needs to. And you want to make sure you're controlling your costs. You want to make sure you're scaling when you need to, and so on. So the cloud provides tools to make that easy. In the cloud, you can easily monitor your resources. That means keeping an eye on performance and a lot more. And we're going to cover that in detail when we get to lesson 11. You'll also have tools that make it easy to scale resources when you need to. And there are even tools that make it easy to automatically scale using rules that you can configure. I'm going to show you a demo of that when we get to lesson 5. You have tools in the cloud to help you budget what you spend. And if you're spending a lot and you're about to blow your budget, the cloud will let you know that proactively so you can ensure that you take the best action to get things back in order. Now, as we talked about in lesson 1, the cloud provides the ability to easily deploy and manage cloud resources. All right, so now we've talked about high availability, we've talked about scaling, agility, elasticity, we've talked about fault tolerance, we've talked about disaster recovery, we've talked about security, governance, and now easy manageability. Now you really know what cloud computing is. It's computers all connected to a network that can take advantage of all of these benefits the cloud provides. There are 3 different cloud service types. In this lesson, you learn that each comes with its own benefits and drawbacks. We cover infrastructure as a service, or IaaS, and the flexibility it provides. We also talk about platform as a service, or PaaS, and how it can make adding powerful functionality simple. And we finish the lesson talking about software as a service, the easiest way to take advantage of the cloud. In lesson 1, we covered the different cloud models, the public cloud, the private cloud, and the hybrid cloud. Now we're going to cover the different cloud service types that are available in these clouds, starting with infrastructure as a service, or IaaS. Now, in an IaaS service, the infrastructure is provided by the cloud provider. Infrastructure refers to things like computers, networking components, hard drives, that kind of thing. In an IaaS service, your costs are typically based on consumption, and this is the service type where you have the greatest responsibility. Now, remember when we covered the shared responsibility model, and I said that how much responsibility you have depends on which service type you use. IaaS has the highest level of responsibility for you, but it also provides you with the greatest level of control. A good example of an IaaS service in Azure is Azure Virtual Machines. And when we get to lesson 5, we'll look at virtual machines in a lot more detail. The next cloud service type is platform as a service, or PaaS. Now, in a PaaS service, it's not just the infrastructure that's provided by the cloud provider, but it's also the operating system and any middleware components that the service needs. PaaS services often offer a large number of easy-to-use features that are also easy to configure, and many of these features are turnkey features that you can use by simply turning them on, making a few minor configuration changes, and you're good to go. PaaS services are usually the best choice when you want to reduce the management burden. Now, in the shared responsibility model, PaaS services offer a good balance between responsibility and control. You have much less responsibility than you do with an IaaS service, but you also have less control and flexibility because the cloud provider makes a lot of your choices for you. An example of a PaaS service is Azure App Service, and we're going to look at a demo of that when we get to lesson 5. The final type of cloud service is software as a service, or SaaS. In a SaaS service, Infrastructure, the OS, and the software itself are all provided by the cloud provider. SaaS services are usually pay-as-you-go services or sometimes even free services. They're also frequently accessed using a web browser or maybe an app on a phone or a tablet or even on a computer. In a SaaS service, you have the least responsibility out of all of the different cloud models, but you also have very little to no control at all over the service. SaaS services are probably the most common type of cloud service, and many people are using SaaS services without even knowing it. Like if you're using a web-based email service like Outlook.com, you're using a SaaS service. If you use OneDrive or a similar online disk-based service, you're using a SaaS service. SaaS services are all over the place, and their ease of use, their convenience, that's one of their greatest advantages. Welcome to Describe Azure Architecture and Services. This is where we'll start to dig into Azure, starting with the core architectural components of Azure, things like Azure regions, data centers, and Azure resources and how you organize them. We'll also cover Azure Compute and networking services, where you'll learn about Azure virtual machines, Azure networking, and how you can host applications and other workloads in Azure. We'll talk about the ways that you can store data and files in Azure, including how you can ensure high availability. And we'll talk about how you can move massive amounts of data from on-premises or another cloud into Azure. We'll talk about identity and security, including how you can authenticate and authorize users in Azure, and how you can give others access to your Azure resources. We'll also talk about ensuring you stay secure when doing so. Microsoft designed Azure to support all the benefits that cloud computing provides. In this lesson, Describe the core architectural components of Azure. You learn a bit about how Azure works under the hood. You learn about Azure regions, region pairs, and sovereign regions, and how they can help you ensure high availability and compliance. We dig further into high availability with a discussion of availability zones. We describe Azure data centers and some of the components within them. We then talk about Azure resources that you deploy to Azure and how you can organize them with resource groups. We also talk about further organizing your resources using management groups and how they differ from resource groups. We've talked a lot about general cloud concepts up to this point. In Module 2, we're going to start getting into some specifics of Microsoft Azure architecture and services. And we'll start that journey with Azure regions and region pairs. Actually, before we talk about regions and region pairs, let's first talk about geographies. Microsoft has divided Azure into boundaries called geographies, and it likely won't surprise you to hear that these boundaries are often defined using the borders of countries, but not always. Some geographies, for example, the Europe geography, are defined by continental borders. Now, whether a geography is defined by a country, a continent, or something else, they're all defined for the purpose of ensuring compliance with regulations that exist in certain parts of the world. As shown in the two example geographies here, the United States and the United Kingdom geographies, there are several regions within each. Now, a region is actually a physical location within the geography. A region contains data centers, and we'll talk more about those soon, and other buildings and facilities that are necessary for Azure to operate. Each region is directly connected to another region that's identified as a region pair, and they do this for disaster recovery. There's a considerable distance between region pairs, geographic distance, usually at least 300 miles. Now, if resources in a region are impacted by a disaster, Azure will automatically fail over to resources in the region pair. Now, this assumes, of course, that you've replicated your Azure resources in both regions of the region pair. Another benefit of region pairs is that if Microsoft needs to update Azure components, it will update those components in one region in the region pair, and then only once they've completed those updates and ensured that the region is fully operational again, will it begin updating the components in the region pair. This ensures that availability isn't impacted by updates to Azure itself. Now, how do you find out what region is a region pair of any particular region? You can find that out on the Microsoft website. Just search for region pairs and they'll have a table that lists them all out. Now, there are also 3 special regions in Azure that are called sovereign regions. And the first of these is the Azure Government region. In Azure Government, all data stays in the US, and only US citizens have access to systems used to store data. Now, these data centers are separated from the public Azure infrastructure, and all employees in these data centers are screened. There's also dedicated networking infrastructure that's completely isolated from other networks. There's even a subset of data centers that are compliant and approved for use by the United States Department of Defense. Now, Azure Government isn't just for the U.S. government. Cities and municipalities can also use it as long as they can prove that they have a governmental affiliation. The next sovereign region is Azure Germany. This region was created to ensure compliance with specific regulations, including the General Data Protection Regulation, or GDPR. It's available to customers who are doing business in the EU. It's also available to customers who are members of the European Free Trade Association, and it's available to the UK. Azure Germany is operated by a company in Germany called T-Systems International, and they operate as what's called a data trustee. They have full control over all the data and infrastructure in Azure Germany. Microsoft only manages systems that have no access to customer data. The third sovereign region is Azure China. Azure China is operated by Shanghai Blue Cloud Technology Company, and it's owned by Beijing 21 Vianet Broadband Data Center Company Limited. This sovereign cloud was created to ensure full compliance with China's policies and regulations. Many Azure regions are enabled with a feature called availability zones. Availability zones is a feature that's designed to protect an application from data center failure. Availability zones are unique physical locations within a region, and there are one or more data centers in each availability zone. In each availability zone enabled region, there are at least 3 availability zones. Now, why the word enabled? Well, I bolded that here because it's important to know that not all Azure regions are enabled for availability zones. Now, to benefit from an availability zone, you need to ensure your Azure resources are deployed to multiple availability zones. And you do this differently depending on whether the service is a zonal service or a zone redundant service. If a service is a zonal service, such as Azure Virtual Machines, you have to choose to deploy the resources to multiple availability zones. If the service is a zone redundant service, such as Azure Storage, Azure itself will replicate your data to multiple availability zones. Once your resource is in multiple availability zones, if one of those zones experiences a failure, you're protected from an availability issue because the data or resource is still operable within the other availability zone. Now, there's an important thing to note here. Availability zones are all within the same region. And remember that a region is a physical location. And that means that availability zones are a good choice for fault tolerance, but they're not a good choice for disaster recovery. If a disaster hits a particular Azure region, there is a chance it could wipe out all of the availability zones that are in that region. We've talked a little about data centers in an Azure region, so let's explore more about what a data center really is. A data center is a physical building within an Azure region, and each region will contain at least 2 data centers. These data centers contain physical hardware, just like your on-premises data center. That means things like network switches, server racks, servers, all that kind of thing. Each data center is climate controlled, and each has its own dedicated network infrastructure. A data center has its own isolated power supply and power generators. And all of the data that flows into and out of a data center flows over cables that are either owned or leased for Microsoft's exclusive use. Now, why do you think Microsoft designed data centers with all these isolated and dedicated components? If you're thinking that it might be about fault tolerance, you're right. No data center depends on power, water, and so on from another data center. They're isolated and they're independent. In Lesson 2, you learned that Azure is designed to support reliability and predictability, and the way data centers are designed is an example of just that. All right, let's shift gears a little bit and let's talk about Azure resources and resource groups. An Azure resource is any entity that you create within Azure. A resource can be something like a web app, a virtual machine, a database, storage for data. There are many different types of Azure resources, far too many for me to list here. Now, each Azure resource is created within what's called a resource group. And a resource group is a logical container designed to help with resource management. Resource groups are a good way to control costs because they allow you to organize your resources in a logical way. They also make it easy to delete a large number of resources when you don't need them anymore. So for example, when I'm working on creating training or writing a book on Azure, I'll often create a lot of Azure resources. And when I'm finished with my project, I can easily delete all those resources I created in one step by simply deleting the resource group. Azure will take care of deleting all of the underlying resources for me without me having to manually delete each resource one by one. Resource groups can also help provide an improved billing experience by using what's called tags, and we'll look at tags more in depth when we get to Lesson 8. You can tag a resource group with a meaningful identifier, and when you get your Azure invoice, you'll be able to see that identifier, that tag, so you can easily identify what the resource group is. You can also sort and filter your Azure invoice by these tags. And finally, a resource group makes it easy to redeploy Azure resources in another region or at a later time using a feature called ARM templates. And again, we'll talk about ARM templates in a bit more detail later in the course. So you've just learned that each Azure resource is created
in a resource group? Well, each resource group is created in your Azure subscription, and resource groups make it easy to organize Azure resources. But what if you have multiple Azure subscriptions? How can you organize those? You can't use a resource group because the resource group is created inside of the Azure subscription. So for that reason, Microsoft created management groups. Management groups provide a way for you to organize Azure subscriptions. In fact, the only thing you can put into a management group is an Azure subscription or another management group. Now, the diagram you see here is just one way you might want to use management groups. In this example, a company has 3 top-level management groups, one for the sales department, one for the IT department, and one for the training department. Within those management groups are the subscriptions that are used by each department. And notice that the IT department also has a second management group for the development team. And in that management group, they have subscriptions that are specific to their developers. Now, how you choose to organize your subscriptions is entirely up to you, but management groups provide that capability for you to do that.
Probably the 2 most common types of services in Azure are compute services, or services that use CPU, memory, disk space, and so on, and networking services. In this lesson, Describe Azure Compute and Networking Services, we talk about the different compute types available in Azure, including Azure Virtual Machines. We then talk about all the different options you have when using virtual machines, and we cover the resources that are required for virtual machines in Azure. We cover the options you have for hosting applications in Azure, including Azure App Service, containers, and more. We introduce the concept of virtual networking and why it's important in Azure, and we define public and private endpoints.
Let's talk about compute types. And let's start that conversation by first defining what we mean by compute. When we say compute, we're referring to a cloud service that consumes resources like CPU and memory. That's it. So now, before we can talk about compute types in detail, we first need to talk about something called containers. Containers represent a method of virtualization for computers. A container is an isolated virtual environment in a computer where an application and the resources it needs can execute. A container is created using an image, which is really just a zip file, and that image contains everything the application needs. That means it contains the operating system, it contains the application itself, it contains any necessary modules that the application might need. If the application needs a database, the image contains that. If the application needs maybe a web server, the image contains that, along with the website the application uses. All of these components are zipped into the image, and then the image is saved onto a repository. Now, to run the application, all you need is a computer that is running the container runtime, and in this case, our computer's running Docker, the most common container runtime today. We point Docker to the image that's in the repository, and Docker downloads the image and runs it in a special environment called a container. Now, containers are very popular because they're an easy way to deploy applications reliably and quickly into different environments. Now, there's one point I want to make about this. Notice that I said the image contains the operating system the application needs. That is true, but it's only the user mode components of the operating system. The container uses the kernel mode OS components of the host computer that's running the container runtime. And that means that if an image is built to run on Linux, it can only run on a host computer that's running Linux. And if an image is built to run on Windows, it can only run on a Windows host computer. Now, both Windows and Linux offer lightweight user mode only versions of their operating systems that are well suited for this kind of thing. All right, so now that that's out of the way, let's talk about some of the compute types that are offered in Azure. First is Azure Virtual Machines. Azure Virtual Machines make it easy to create a virtual machine that's running either Windows or Linux. And you can choose between a broad array of machine sizes and configurations. Azure will actually pre-install the operating system that you choose onto that VM. And Azure VMs are an IaaS service. We talked about that a little bit before. So once you create the VM, you will have to configure the OS, install any additional components, and deploy the application yourself. The next type of compute is Azure Container Instances, or ACI. And this compute type makes use of, you guessed it, containers. Now, the really cool thing about ACI is that you can just point ACI to your image, and it will run the image in a container without you having to create a VM to run it on. You only pay for the memory and the CPU used by your container. You only pay for the compute part. You don't pay for the underlying VM itself. Now, you can also use container groups if you want to run multiple containers in a single ACI instance. ACI is designed for small workloads that perform an operation quickly. If you need heavy usage or an application that's available for long periods of time, a service like Azure Kubernetes Service is probably a better option. Another cool compute type in Azure that's great for performing quick operations is Azure Functions. Functions is designed for microservices that take input, perform an operation, and return a result. Functions are event-driven, so you can run a function, for example, when a file is uploaded to a particular folder or something like that. Functions can run in a consumption-based model, which means that, like ACI, you don't pay for any VMs. You only pay for the compute resources that your function uses. Up to this point, I've talked a lot about Azure Virtual Machines. Let's go into a bit more detail about Azure Virtual Machines. Azure Virtual Machines simply are just VMs in the cloud, and both Windows and Linux are available. Each VM is a guest on a host computer that's running in a server rack in an Azure data center. If you stop an Azure VM, it's deallocated and you're no longer billed for it. Now, you can easily start it back up again when you need it, and then billing for it will resume. VMs also offer a feature called availability sets that help you with high availability. Now, this is not the same as availability zones, so let's have a look at what availability sets offer. An availability set consists of two different components, fault domains and update domains. Both of these components provide fault tolerance, but they address different concerns. A fault domain is a logical representation of a physical server rack in an Azure data center. They're designed to protect you from a fault that might occur in a hardware rack. An update domain is a logical construct that's designed to ensure availability when a VM needs to reboot for an update. When a VM requires an update that needs to reboot the machine, Azure will only update one update domain at a time, and only once the VMs in the first update domain have rebooted and are back online and available will it move to update the VMs in the next update domain. Now, in the diagram shown here, I have 5 VMs. When I created these VMs, I chose to create them in an availability set. And I specified that I wanted 2 fault domains and 3 update domains in that availability set. This resulted in the configuration you see here. And this configuration makes my VMs fault tolerant for problems that are in a server rack and for reboots due to updates. Now, another option that you have with VMs is called Virtual Machine Scale Sets, or VMSS. VMSS allows you to scale virtual machines. And when you create a VMSS, you specify the OS and how many VMs you want in the scale set. Each VM is an exact copy of the other VMs. VMs in a VMSS are scaled using an Azure service called Autoscale, and all VMs in VMSS are deployed using availability sets for fault tolerance. Now, VMs and containers aren't the only virtualized environments you can use in Azure. You can also use a service called Azure Virtual Desktop. Azure Virtual Desktop is desktop virtualization in the cloud. And desktop virtualization allows users to run applications in a virtualized environment without having to install those applications on their own computer. The desktop virtualization environment makes it seem like the applications are running locally, but they're actually running on another computer. And this is a common technique used by companies to offer software to users because it gives them much more control over security and configuration. Azure Virtual Desktop offers clients for Windows, Mac OS, iOS, iPadOS, and Android. And it will also run inside of a web browser, so you can use it with just about any other kind of computer, tablet, or phone. Users also get their own user profile, so they can use profile-specific services, maybe like OneDrive. Let's look at the resources that are required for a virtual machine in Azure. And probably the easiest way to do that, or the best way to do that, is to just look at a virtual machine. So let's head over to the Azure portal, we'll create a virtual machine, and then we'll have a look at the resources that are created for that virtual machine. So this is the Azure portal, and I've logged into my subscription. And just as with many things in the Azure portal, there are a lot of different ways you can create a virtual machine. I'm going to click on virtual machines right here, and you'll see I don't have any. So I'm going to go ahead and click on create and create a virtual machine right here in the portal. So remember we talked about resource groups. The first thing I'm going to do is create a new resource group called AZ-900. Now I need to give my virtual machine a name. I'm going to be very creative here and call it VM1. I'm going to create this in the central US region. That's the region that's probably geographically closest to me. And notice the next option here is availability options. And we talked a little bit about these up to this point in the course. So if I drop down this drop down here, right now it says availability zone, but notice I also have virtual machine scale set and availability sets that I can choose from. So that's how you set the availability options. And I'm just going to leave it at availability zone. I'm going to deploy this to zone 1. This image dropdown allows me to select the operating system image that I want Azure to install on that virtual machine. And I can choose from either Windows or Linux, and there are lots of different flavors of each. So if I wanted to create, for example, an Ubuntu server, version 20.04, I can just select that here. I can select the architecture. We're not going to talk about Azure Spot discount at this point. I can select the size of the VM, and this is how powerful the VM is. And notice that as you go to a more powerful virtual machine, you pay more for that virtual machine. I'm going to go ahead and use SSH public key. That's for remote access. And I'm going to just leave all of the rest of the options at their default value, and I'm going to click on Review and Create. That's going to do a check, just make sure that I've given all of the information that Azure needs to create the virtual machine. And then I'll get this Create button where I can go ahead and kick that process off. I'm going to download a private key and create a resource. That's so that I can use an SSH key, and you see it's downloading that to my machine here. And we see now that the deployment is in progress. And so this is going to start creating all of the different resources that are necessary for me to run a virtual machine in Azure. And it's going to take just a minute or two to do that. And now we can see that's finished. So I can click on Go to Resource, and that will allow me to open that virtual machine here in Azure. So I can see here that this is in the AZ-900 resource group. But what we really want to see are what are all the different resources that are required for a virtual machine. And probably the easiest way to do that is to look at that resource group, because this virtual machine is the only thing that's in that resource group. Remember, I created the resource group when I created the virtual machine. So let's go back to the home page of the portal, and here's that resource group that I created. I'm going to click on that, and it's going to show me everything that's in there. So interesting. Remember, all I did was create a virtual machine. I didn't explicitly create anything except a virtual machine. And when that happened, I got a virtual network. I got the virtual machine itself. I also got a public IP address, a network security group, a virtual network interface. And because I chose a Linux operating system and told it that I wanted to use SSH for remote access, I also got an SSH key. And then I have this, which is the operating system disk. So with the exception of the SSH key, all of the other resources that you see here are going to be created every time you create a virtual machine. Doesn't matter whether it's a Windows machine or a Linux machine. You're going to get all of these resources. And that's necessary because in order for you to be able to connect your virtual machine to other things, in order for you to be able to access it over the internet, you have to have all of these other components, just as you would with a physical machine. And it's worth pointing out that this is one of the benefits you have by putting everything in a single resource group. Because if I want to delete all of these resources in one step, I can just delete that resource group. And that's kind of important because if I go back to the home page and then I select this right here, which shows me all of my resources, you'll see that I have quite a few things that exist in my Azure subscription, even though all I've created is a single virtual machine. And so I might look at this and say, I'm not exactly sure what VM120_Z1 is or what it belongs to. But as long as I have used a resource group to put those things in, I can tell immediately that this must be related to that virtual machine that I created because it's in this AZ-900 resource group. Let's talk about your options for hosting apps in Azure. And we'll start with a popular Azure service called Azure App Service. Now, Azure App Service is a PaaS service that can be used to easily create and host web apps in the cloud. The diagram that I'm showing here is a high-level view of how App Service works. So each App Service deployment in Azure data centers, Microsoft's deployment of the app service has several front ends. And these front ends use a customized proxy-based routing module to send a request to a virtual machine that's hosting the app that's being requested. The virtual machines running a web app, whether that's one VM or many VMs, run within what's called an app service plan, which is a logical unit that just helps with scaling web apps. When you create a web app, you specify which app service plan you want to host it in. And that app service plan defines the tier that you're using for hosting. Lower tiers have a lower cost, less power, often have fewer features. Higher tiers have more features and more powerful VMs. When you create new apps in that same app service plan, they will run on the same VMs. That means if you have multiple VMs in an app service plan, they're all exact copies of each other, including the apps that's running on them. The best way to see how app service works is to see it in action. So let's go back over to the Azure portal and let's create a web app and have a look at it. Okay, so here in the portal, we're going to create a web app. This icon right here is for app service. And you see I have no app services, no web apps or anything. So just like we did with a virtual machine, let's create one. So in this case, I'm going to put it in the same resource group that I had my virtual machine in. I'm going to drop this down and I'm going to choose AZ-900. And now I'm going to give this a name. Now, the virtual machine name that I used has to be unique inside of my subscription. So I can't create two virtual machines called VM1 in my subscription. But someone else with a different Azure subscription, they can create a VM called VM1, even if I have a VM called VM1. App service doesn't work that way. The name that you give your web app has to be unique across all of Azure App Service, all of the customers who have created web apps. And the reason for that is because this is a DNS name. So I'm going to call this AZ-900WA. Notice when I just had AZ-900, it told me it's not available. That means someone else, somewhere, has a web app called AZ-900. So I'm just going to call it AZ-900WA. And notice underneath this box, it says .azurewebsites.net. That means that once I create this, I can browse to it by just browsing to AZ-900WA.azurewebsites.net. That's why it has to be unique across all of Azure. So I have three different options here. I have code, Docker container, or static web app. Remember we talked about Docker containers earlier. Just for simplicity, I'm going to just use code, which means I now have to give it a runtime stat. Now remember, this is a PaaS service. So that means that Microsoft, the cloud provider, has given me certain options that are pre-configured that I can choose from. Makes it really easy. It removes some of that complexity from me. But it also means I have a little bit less control because it's a PaaS service. So notice here I have Java 8, 11, and 17. What if I wanted a different version of Java? Can't use a different version of Java. You have to use what the cloud provider gives you, okay? So I'm just going to choose ASP.NET 4.8. That's fine. ASP.NET 4.8 runs on Windows. It's not a version of .NET that'll run on Linux. And so now Linux is grayed out. If I chose something like Node or PHP or something like that, then I would be able to choose either Linux or Windows, either one. Central US is fine. Now, right here in the pricing plans, notice it says Windows Plan Central US. That's an app service plan. And you can see that it's going to create a new app service plan with this really cryptic name. I'm going to click Create New so that I can choose my own name. And I can call this whatever I want, GEMS ASP. And now that I've got that name in here, I can look at the pricing plan for my app service plan. Right now, it's recommending standard S1, gives me some different attributes of that particular pricing plan. If I click on change size, I can choose a different pricing plan. And I'm going to show you a little bit more of that here in just a minute. So for now, let's just leave it at the default. And everything else, we're just going to leave as it is and click review and create. And now I'm going to click create to create that. Now, creating a web app and app service is way faster than creating a virtual machine, because that virtual machine that this is going to run on is already sitting there waiting on someone to create a web app within it. And so a few seconds later, I'm ready to go. So let's go to that resource. And this is my web app running inside of Azure. Here's the URL that I mentioned before. And if I go to that right now, you'll see it's just waiting for content. Wants me to deploy something to it. Right now, there's nothing there. But I do want to look at a few things here about app service, because we've talked about these a little bit. We kind of looked at the app service plan. Let's scroll down here and look at the scaling options. Remember when we talked about scalability, and I talked about the fact that you can scale up and down, meaning a more powerful or a less powerful machine. And then you can scale out. And remember, that was adding more exact copies of a machine. So going from one machine to 2 machines or 3 machines. I also talked about the fact that cloud providers try to make that really easy on you. So let's look and see how easy that is exactly. If I click scale up, and notice it says app service plan, that means any scaling operation applies to the app service plan. If I have 2 different web apps running in the same app service plan, they are running on the same virtual machines. And so when I perform a scaling operation, that applies to all of the apps running in that app service plan. Okay, so I have quite a few different options here. If I scroll down, I see that I have right now the S1 tier. That's where I am. Notice it's got a little box around it. I can go to S2 or S3. Each time I go up, notice I'm getting more memory. I'm also paying more money. So if I go to an S2 machine and I click apply right here, that change will actually take effect relatively quickly. If I click apply, no video magic or anything just happened right there. It's done. So my web app is now running on a different virtual machine than the one it was on before. And that happened super fast. I didn't have to create anything myself. And again, I can scale back down too. I just apply that. It's that fast. It's literally that fast. All right, so let's look at scale out. And remember, scale out, adding more copies of the same virtual machine. So in this case, I'm running 1. You can see I'm running 1 here. If I want to run that on, let's say 3, I can just move this slider to 3 and then save that. And what's happening right now is App Service is copying my app to 2 additional virtual machines, and then it's adding those virtual machines into my app service plan. And it did that and completed it before I could even get that sentence out of my mouth. That's how fast this stuff is. So that's really cool. And again, I can scale back down again. But, you know, it's ideal if this could happen automatically for you. I mean, it doesn't make any sense that you would want to sit there and watch your metrics and say, oh, wow, I probably ought to scale out. So you have this option to create custom rules that you can use to scale based on metrics. So you can say, let's say, for example, your web app is featured on some really popular news source, maybe a YouTube channel that a lot of people watch, or maybe your local news channel or something like that. And all of a sudden, you're getting a lot of traffic that you're not really expecting. You can set up metrics that app service will watch for you. And when it meets certain conditions, it can actually automatically scale for you so that you maintain availability. And you can also create additional rules that say, once that load has diminished, start scaling back, start reducing the number of instances. And so by using this auto scale functionality, you can very easily take advantage of that consumption-based model. You can very easily scale in an elastic way based upon your needs and make sure that you're not spending more money than you need to. So great feature, really cool. Another thing that I talked about when I covered PaaS services is that they often offer like these turnkey features that make things really easy to configure and control. And let's look at one of those when it comes to app service. Let's go to authentication right here in the menu. So let's say, for example, I don't want everyone to be able to access my web app. I want to be able to authenticate people. And you have to log in to access my web app. But I don't want to create my own component to authenticate you. I'd rather allow you to sign in with your Microsoft account, for example. If you were to implement this web app in an IaaS VM, and so the web app is something you've developed and you want to add that kind of functionality, you would have to write an authentication provider or use one that somebody else has written and configure it to work with your app. But with a PaaS service, it's way easier. I'm just going to click Add Identity Provider, and I can select from this dropdown a whole bunch of different identity providers. So I can let someone log in with their Microsoft ID, their Apple ID, their Facebook login, their GitHub login. The list goes on, right? And the cool thing here is all you have to do is provide a little bit of information from the identity provider, stick that into some text boxes, click a button, and it turns it on and it's working. So that's the cool benefit of using a PaaS service. It allows you this turnkey functionality that you can turn on simply by enabling something within an easy-to-use interface versus you having to do it yourself. And now you see why people are so attracted to using a PaaS service. Kind of sits right there in the middle, that metric that determines how much responsibility you have versus how much flexibility you have. So again, you're giving up a little bit of flexibility, but you're getting a whole lot of functionality in return for that without you having to be responsible for that. So that's Azure App Service. Pretty cool service, probably one of the most popular services in Azure. Lots of people use it. Now, earlier in this lesson, we talked about containers and Azure container instances. And when we talked about that, I told you that you'll probably want to use Azure Kubernetes Service, or AKS, if you need a powerful containers solution. Kubernetes is a powerful container orchestration service, which is just really a fancy way of saying that it excels at scaling containers and making sure they're available when you need them to be. AKS is Microsoft's implementation of Kubernetes in the cloud, making it way easier to adopt Kubernetes because you don't have to manage it yourself. Kubernetes runs in a cluster with two different types of computers. One is the control plane, which is the primary computer that controls the cluster. And then you have nodes, which are the computers that run your containers. The control plane orchestrates the cluster, meaning it's responsible for scaling to new instances of containers or scaling in when you no longer need additional containers. Much like Azure Container Instances, you only pay for the compute resources that are in your cluster. Now, another hosting option in Azure is to simply use a virtual machine. And this is, of course, the most flexible option, but since you're using IaaS when you use VMs, installation, configuration, all your responsibility. Just as I talked about when we were looking at app service, if you use a virtual machine, security, your responsibility, and any additional components that you need, all your responsibility. So obviously, virtual machines as an application hosting option gives you the most flexibility, but also way more responsibility. So we've talked about virtual machines and application hosting options. Let's add another ingredient to this mix, and let's talk about virtual networking in Azure. Azure Virtual Networks enable you to configure your networking in Azure just as you might on premises, but without the hassle of configuring networking hardware, running cables, all that kind of thing. Now, pictured here is a typical network configuration for a multi-tiered application. Notice that the virtual network has an IP address space specified in classless interdomain routing format as 10.0.0.0/16. That means that this network has 65,534 usable IP addresses. Now, I've also created 3 subnets, each one with 254 usable IP addresses. Subnet 1 is my web tier, and this is where I'm hosting the website that provides the user interface for my application. Subnet 2 is my middle tier, where I'm implementing some business rules, data validation, that kind of stuff. And subnet 3 is my data tier, where I'm storing all the data that the application uses. Now, as a best practice, you would not want a machine that's in subnet 1 to be able to talk directly to subnet 3. And you wouldn't want any subnets other than subnet 1 to have access to the internet. And you can achieve all of this with Azure Virtual Networks and much more actually as well. So Azure Virtual Networks ultimately allow you to lift and shift your entire network topology from on-premises to the cloud. And there's plenty of capability to enable future growth as your network grows. Now, of course, you aren't limited to a single virtual network. You can create multiple networks in Azure based on your needs. And when you do, you might find that you need to connect resources that are in different virtual networks. And to do that, Azure offers a feature called Virtual Network Peering. Virtual network peering makes it possible to connect 2 Azure virtual networks together. And when you peer 2 virtual networks, the traffic travels over Microsoft's private backbone network, not the internet. So for this reason, peered traffic is not encrypted. And one important note here, you can peer networks that are in the same region or in different regions. And when you peer networks that are in 2 Azure regions, it's called global virtual network peering. Now, the next service we'll talk about, the next networking service, is Azure DNS. Azure DNS is a service that makes it easy to manage your domain name system or DNS records in Azure. So if you've ever hosted your own website, you know that you need to manage DNS records like A records and CNAME records and MX records and all of those. Azure DNS makes it easy to do that in the cloud, making it even easier to configure networking with your Azure service. In Azure DNS, internet-facing zones are called public zones, and zones that are just used for Azure Virtual Networks are called private zones. Next, let's talk about Azure VPN Gateway. Azure VPN Gateway allows you to create secure connections between Azure Virtual Networks and other networks. So when you create an instance of VPN Gateway, you get a subnet called the Gateway subnet. That automatically gets created for you. And inside of that Gateway subnet, you'll find 2 or more VMs that are used to implement the functionality of VPN Gateway. You don't pay for those VMs, you can't connect to them, you can't manage them. They are only used for a VPN gateway. There are 3 different types of VPN gateways. There's VNet to VNet, which allows you to connect 2 Azure virtual networks together using VPN gateway. There's site to site, which allows you to connect an Azure virtual network to another network that's outside of Azure. And then there's point to site, which allows you to connect a single device, such as a smartphone or a computer, to an Azure virtual network. Now, one key point about Azure VPN Gateway: your network speed is limited to 1.25 gigabits per second. You also pay for the overhead of dealing with encrypted network traffic. These points are especially important if you're trying to decide between VPN Gateway and virtual network peering for connecting 2 Azure networks together. Okay, our next stop on this tour of Azure networking brings us to Azure ExpressRoute. And like VPN Gateway, ExpressRoute lets you connect Azure resources to on-premises resources. But unlike VPN Gateway, ExpressRoute offers speeds up to 10 gigabits per second over dedicated fiber and up to 100 gigabits per second if you use ExpressRoute Direct, which is a high-level offering that connects you directly to Microsoft's network. Another advantage to ExpressRoute is that traffic doesn't flow over the internet. Instead, you connect directly via a Microsoft Enterprise Edge router, or MSEE. Now, when you're using ExpressRoute, you'll typically connect using a third-party provider, and that provider is usually an internet service provider. The provider will have a direct connection to that MSEE, and the MSEE is in turn connected directly to Microsoft's network in Azure. And a key point here is that Microsoft calls an ExpressRoute connection a circuit. We'll close out this lesson with a definition of public and private endpoints. This is actually a very simple concept. A public endpoint is a resource that has an IP address that's reachable over the internet. A private endpoint has an IP address that is only reachable over a private network. It's really that simple. And a key point here is that a resource can have both a public and a private endpoint. Remember when we were looking at the resources that were created when we created that virtual machine earlier? A virtual network was created. That virtual network had a private address space with a private endpoint for our virtual machine. But we also had a public IP address resource. And that public IP address resource provides us with a public endpoint for that virtual machine.
Applications are definitely important in cloud deployments, but the underlying data applications use is just as important. In this lesson, Describe Azure Storage Services, we look at the different options available in Azure for storage. We begin by comparing the different storage services available, from blob storage to Azure Files to Azure Disks. We then discuss storage tiers and how choosing the right tier can help you control costs. We talk about storage redundancy options so you can ensure high availability for your data. We cover the storage account in Azure and the different types of storage accounts that are available to you. We then talk about moving files into Azure Storage and methods for doing so, from command line options to drag and drop options. And then we move on to a discussion of options available for migrating massive amounts of data into Azure Storage.
So now we've talked about some of the ways that you can host applications in the cloud. We've also covered uses for virtual machines. We've talked about networking in the cloud and how you can connect networks both in the cloud and on premises. Now let's talk about another important aspect of cloud deployments, and that's storage. Storage in the cloud refers to anything you need to store, whether that's for use by an application or simply for backup or archival purposes. Let's begin by talking about Azure Blob Storage. Blob storage is designed for storing unstructured files, things like pictures, audio files, videos, documents, that kind of stuff. And a file that's stored in blob storage is called a blob. And blobs are stored in containers. You can think of a container as being similar to a folder on your hard drive. It's a convenient way to organize blobs in blob storage. There are three types of blobs in blob storage. Block blobs are files that might be used by an application, things like pictures, videos, audio files, documents, all those things I mentioned earlier. Append blobs are blobs that are specialized for append operations. For example, maybe you have an application that writes to a log file of some kind. An append blob is a great option for that kind of thing because you're appending to an existing blob. And the third type of blob is called a page blob, and these are blobs that are used to store virtual hard disk files, or VHDs, that are used by virtual machines. Another storage service available in Azure is Azure Disks. Azure Disks stores disks that are used in virtual machines, and they're available as either spinning platter disks, regular old hard drives, or solid-state drives. When you create a virtual machine, Azure creates an OS disk for the operating system. We saw that earlier when we were looking at the resources that were created when we created a virtual machine. However, if you want to write persistent data to the VM, you'll need to create a separate disk called a data disk. And these data disks are stored in Azure Disks. Another storage service in Azure is Azure Files. Azure Files is an SMB, or a server message block, based service that provides disk space in the cloud. If you've ever used a map drive on a network or access data using the format of / server name / share name, you've used SMB. And that's exactly how you access files that are stored in Azure Files. Now, you might realize that accessing files stored in Azure using this method might be slow because they have to travel over the internet. And that's true. And for that reason, Microsoft provides a utility called Azure File Sync that allows you to synchronize files in Azure Files locally to a server on your network. And then users can access that local server to benefit from the speed that it offers, but you still have your files stored securely in the cloud with Azure Files. Blobs in Azure Blob Storage are stored in one of three storage tiers. The hot tier is for data that you access frequently. Azure Storage is priced by not only how much space you use, but by data operations and transfers, meaning when you read data, write data, and so on. So blobs in the hot tier have the highest cost of storage, but those access costs are the lowest. The next storage tier is the cool tier. And this is for data that you want to store for longer periods of time. In the cool tier, storage costs are lower than the hot tier, but the access costs are higher. Data that you store in the cool tier must be stored for at least 30 days. If you remove a blob in the cool tier prior to 30 days, you'll be charged a prorated penalty fee. And by remove, that means either deleting it or moving it to another tier. And finally, the archive tier is for long-term storage. In the archive tier, you have the lowest cost of storage, but your access costs are the highest. Blobs that are in the archive tier must be stored for at least 180 days, Otherwise, you get subjected to that prorated penalty fee just as you are in the cool tier. Now, if you want to use a blob that's in the archive tier, you'll first need to move it to the cool or the hot tier in a process that's referred to as hydrating the blob. And when you do this, you're guaranteed access to the first byte of data within 15 hours, although in reality, it's usually way shorter than that. Let's talk about a concept we talked about way back in lesson 2, and that's high availability. How does Azure Storage ensure high availability? Well, it does this by using one of several different redundancy options. And the first one is called locally redundant storage, or LRS. LRS is the least expensive redundancy option, but it's also the least durable. So in LRS, Microsoft creates 3 copies of your data in the same data center. Now remember, a data center is a specific building at an Azure region. So if there's a problem that impacts that entire building, you could lose access to your data if you're using LRS. And that's what I mean when I say LRS is the least durable option. The next redundancy option is called Zone Redundant Storage, or ZRS. ZRS is more durable because it creates 3 copies of your data, and each is in a separate availability zone. Now remember from lesson 2 that an availability zone contains at least 1 Azure data center, and there are at least 3 availability zones in each enabled region. So that means that with ZRS, your data is copied to multiple data centers. So you're no longer going to be impacted if a problem occurs in a single data center. Now, whether you choose LRS or ZRS, your data is always going to be stored in the same Azure region. And because of that, these 2 options are referred to as primary region redundancy. Primary region redundancy offers fault tolerance, but it's not a good plan for disaster recovery. For even more durable redundancy and protection from a large-scale disaster, you can choose from a couple of different multiple region redundancy options. And the first is Geo-Redundant Storage, or GRS. In GRS, you get 3 copies of your data in the same data center using LRS, and then you get 3 additional LRS copies in another data center that's in a region that's far away from your primary region. You could also choose Geo-Zone Redundant Storage, or GZRS. In GZRS, you get 3 copies of your data using ZRS, so 3 copies in different availability zones. And you also get 3 additional LRS copies in another data center that's far away. All of your Azure storage objects are stored in a storage account that's in your subscription. And there are several different types of storage accounts available. The first is the standard general purpose V2 storage account. And this is the type of storage account that's recommended for most purposes. The general purpose V2 storage account is a standard account for blob storage and Azure files, and also for queue storage and table storage, 2 additional storage options that you have in Azure. It offers all of the different redundancy options that we just discussed. Azure also offers premium storage account types, the first being the premium block blobs storage type. Now say that 3 times fast. This storage account type is for block blobs and append blobs that are in blob storage, and it offers both LRS and ZRS redundancy options. Next is the premium file share storage account type, and this is for file shares in Azure files. Like the premium block blob storage account type, premium file shares support both LRS and ZRS redundancy. And the final premium storage account type is premium page blobs. This is for storage of page blobs, and it supports LRS redundancy. Now, one final point about these premium storage account types, they all use solid-state drives for maximum performance. So now that we've covered many of the Azure storage options that are available to you, let's talk about how you can interact with your files in Azure storage. The first method is AZ copy, which is a command line tool that you can use to copy blobs and files to and from Azure storage. Using AZ copy, you can copy individual files, but you can also copy entire directories in one operation. Of course, moving files to and from Azure storage isn't all you can do with AZ copy. Using AZ copy, you can do just about anything that you'd want to do with Azure storage, including giving others access to your data, which is a concept we'll talk about more when we get to lesson 7. AZ copy is a popular method for moving files in Azure storage because it's a command line tool, and that means it can be scripted. And if you or someone else in your company is used to writing scripts to automate tasks, AZ copy can easily be incorporated so that you can more efficiently manage your files in Azure storage. However, if you're not the command line type, there's an option you might find more useful, and that's Azure Storage Explorer. Storage Explorer offers an easy-to-use interface for interacting with Azure storage and your data. And Storage Explorer was developed using Microsoft's .NET Standard Library, and that means that it's cross-platform, available for Windows, Mac OS, and Linux. Using Storage Explorer, you can copy data to and from storage containers, you can generate shared access signature or SAS tokens, which grant others access to your data in a secure and controlled way. You can change storage tiers of your data in storage, and you can create and manage storage containers. So let's have a look at Azure Storage Explorer. This will give you a better idea of what it offers, and it'll allow me the opportunity to demonstrate some of these other Azure storage concepts that we've talked about. And here we are in Microsoft Azure Storage Explorer. Now, I have already created a storage account. I don't have anything in that storage account yet, but if I expand storage accounts right here, I can see that I have a storage account. Now, before I did that, I connected Storage Explorer to my Azure subscription. And when you first launch it, you'll have the ability to do that as well. It just simply launches a web browser, you log in, and it connects you, and you can see all of your resources right here within Storage Explorer. So what I would like to do is create a container so that I can add a file into blob storage. And remember, I said you can think of a container as kind of a same thing as a file folder or a directory on your hard drive. So I'll expand my storage account, and I see I have blob containers here. I do have one container already, which was created when I created my storage account, and that just has logs in it. I'm not going to use that. I'm going to right click right here on blob containers, and I'm going to choose create blob container, and I'm going to call this pictures. Now, you can't use uppercase letters in a container name, so I'm using lowercase p. So now I have a blob container, and it's empty. There's nothing in it. How do I get something into that? Well, I could use AZ copy, like I told you before, or I can just use Storage Explorer. So let's look at the pictures directory right here on my computer, and I have this really cool picture of a piano. I'm just going to drag that and drop it right here into this container. And we see down at the bottom there that it's now transferring that over, and it's done. So now I have a picture stored in blob storage. And notice that the access tier is hot. By default, it's going to stick it in the hot tier. If I wanted to, I could change that to the cool tier. I can right click on this and I can choose Change Access Tier. And now I can move it into either the cool tier or the archive tier right here within this interface. And by the way, if I had multiple blobs in here, I could select multiples just the same way you do on your hard drive when you select files. And I can apply an operation to multiple ones. The other interesting thing that you can do in Storage Explorer is create a SaaS token. Let's say, for example, that I want to give someone access to my pictures container. I can right-click right here, and then I can choose Get Shared Access Signature. And this allows me to specify a start time and an expiration time for this particular key. So you can see right now as I record this, it's the 19th of November. So this key by default is good for 24 hours. I can change that if I want to. I can make it last longer. I can also choose whether those time zones are local or UTC, and I can determine what permissions I want someone to have. Now notice by default, you get read and list, which means if someone uses this shared access signature token to access my container, they would be able to list out the different blobs that are in it, and they would be able to copy them down using that read access. So once I click create, I get these strings which represent the SaaS token. And I can provide that to someone and they can use that inside of Storage Explorer or with AZ Copy or other areas that access Azure Storage to actually gain access to my container that I'm setting up the SaaS key for. And the cool thing about this is when that expiration date and time is hit, it won't work anymore. So I don't have to worry about going in and removing this. It will only work for the amount of time that I specify. So that is Microsoft Azure Storage Explorer. All right, so let's talk about one more option for interacting with files in Azure Storage, specifically in Azure Files, and that's Azure File Sync. Now, I mentioned this briefly when we were talking about Azure Files. Azure File Sync is a utility to sync Azure files to on-premises servers. And to use Azure File Sync, you install it to an on-premise server, and it will then speed your access to Azure Files data because you no longer have to transfer that data across the internet. The tools we just looked at, great for moving files into Azure Storage, but now we're going to look at ways that you can migrate much more to Azure, including situations where you might need to move massive amounts of data to Azure Storage. And we're going to start by looking at Azure Migrate. Azure Migrate helps you to migrate to Azure, including the migration of servers, databases, web apps, and more. And these resources can certainly be on premises, but you can also migrate from other cloud providers to Azure using Azure Migrate. Now, there are 3 steps involved in using Azure Migrate. The first is the discovery step. And in this step, you use software called the Azure Migrate Appliance that runs on a dedicated Windows server, either a physical server or a virtual machine. Now, the job of the appliance is to discover the servers, databases, and web apps that are in your environment. And it also collects and sends metadata and performance data on these resources to Azure Migrate that's running in Azure, and it does that on a regular basis. And it also does that using an Azure Express Route connection, so it's very fast. This discovery process typically takes about an hour for the appliance to discover up to maybe 500 servers. And then if you have more servers, it could actually take longer than that, obviously. So once that discovery process is complete, the application will begin to collect information on the software that's installed on those servers. Now, once the entire discovery phase is complete, you can group all of the discovered resources and assess them. And during this assessment phase, Azure Migrate uses the information it discovered, including all that performance data, and it recommends configurations in Azure for your resources. So for example, Azure Migrate will recommend VM sizes and disk types for virtual machines that are in Azure using performance data that is collected by the Azure Migrate appliance. Now, after the assessment, you can use Azure Migrate to develop and execute an automated migration of your resources. And it will even let you run a test migration so you can find any problems before you do that full-scale migration. So Azure Migrate provides a great way of migrating servers, databases, and web apps to Azure. But what about migrating your data? I mean, we talked about using Storage Explorer and AZ Copy to copy data to Azure Storage, but what if you have enormous amounts of data, possibly hundreds of terabytes? Using those methods might not be optimal, especially in cases where you have limited or maybe even no connectivity to the internet. So for those types of scenarios, Microsoft offers Azure Data Box. Azure Data Box is for the migration of massive amounts of data to Azure Storage. And it comes in 3 different offerings that are suited to different needs. First is DataBox Disk. So using DataBox Disk, you place an order for DataBox Disk in the Azure portal, and Microsoft then sends you up to 5 SSDs, each with around 7 terabytes of capacity. So once you receive those disks, you connect them to a computer on your network, you copy your data to them, and then you ship them back to Microsoft where they'll be imported into Azure Storage for you. This might seem a little risky at first, but the SSDs used with DataBox disk are secure. They're in a tamper-resistant enclosure. The data on the disk is encrypted with AES 128-bit encryption, and they can only be accessed using a secure key. Also, Microsoft erases those disks in compliance with NIST 800-88R1 standards once the data has been copied to Azure Storage. Now, for even more data, you can use DataBox. And unlike DataBox Disk, DataBox is an appliance that is ruggedized. So once you receive that appliance, you plug it into a power supply and you connect it to your network. DataBox contains up to 80 terabytes of disk space, and it's in a RAID 5 configuration. So like DataBox disks, once you copy your data to the DataBox appliance, you just ship it back to Microsoft, and they import the data into Azure Storage. The DataBox appliance is specially designed with tamper-resistant screws, and Microsoft applies security stickers to deter tampering. And like DataBox Disk, data is secured with AES encryption, but DataBox uses 256-bit encryption instead of DataBox Disk's 128-bit encryption. And the disks are also wiped using NIST 800-88R1 standards after your data is copied to Azure Storage. So if you have even more data, up to hundreds of terabytes, you can use DataBox Heavy. And DataBox Heavy also uses a physical device, but it's a massive one. It contains up to 1 petabyte of disk space, of which about 770 terabytes is usable by you. DataBox Heavy is shipped using a freight company, and the device is delivered on a wheeled cart so you can move it around easily. It's big. DataBox Heavy has the same security features as DataBox, and it also includes a web-based user interface that runs locally on the device, and it makes it easy to configure the device and connect it to the DataBox service in Azure. You use DataBox Heavy just as you do the other Azure DataBox offerings. You copy your data to the device, and then you ship it back to Microsoft where your data is copied to Azure Storage. Now, before we move on, let me point out one distinction between DataBox Disk and other DataBox offerings. DataBox Disk, that's the one where you get the SSD drives, can only be used with one storage account, whereas DataBox and DataBox Heavy can be used with up to 10 storage accounts, so keep that in mind.
In today's climate, security is certainly one of the most important concepts in computing. In this lesson, Describe Identity, Access, and Security, we talk about how you can implement authentication, authorization, and access control in Azure. We discuss directory services in Azure, including a discussion of Azure Active Directory. And we talk about how you can expand directory services from Azure into your on-premises environment and into other clouds. We discuss authentication methods available in Azure, from multi-factor authentication to passwordless authentication and more. We talk about how conditional access can ensure security when people bring their own devices into your environment. And we talk about how you can control the level of access authenticated users have to your Azure resources using role-based access control. We talk about the concepts of zero trust and defense in depth. And we talk about how Microsoft Defender for Cloud can help you with ensuring you have a secure posture when it comes to all your resources, not only in Azure, but also in other clouds and on premises.
If you think about what's required to secure resources, certainly one of the most important things you need to know is who or what is accessing a particular resource. And to do that, you need to have an identity service. In Azure, Azure Active Directory fills that need. Azure Active Directory is a cloud-based identity service that authenticates and authorizes users. Authentication is the process of identifying who or what is attempting to access a resource, and authorization is the process of identifying what that person or resource can do once it's been authenticated. Azure Active Directory can give authenticated resources access to not only Azure resources, but also third-party resources and resources on premises. Once authenticated, a resource can be authorized to perform certain actions using identities and directory roles, and we'll dig into that more and see a demo later in this lesson. In addition to these identities, Azure Active Directory can also use service principals, which are applications in Azure Active Directory, something I'll demo here in just a minute. And also managed identities, which represent Azure resources. So for example, you could use a managed identity to give a web app access to a virtual machine. So let's go back to the Azure portal and let's have a look at Azure Active Directory in action. So you don't have to create an instance of Azure Active Directory. It's already there. If you have an Azure subscription, you have Azure Active Directory. So to find it, I'm just going to click right here in the search bar and I'm going to enter Active. And I'll see right here, Azure Active Directory. So I'm going to click that. And that takes me into my instance of Azure Active Directory. So a couple of things I'm going to show you here. One is users. So if I click users right here, I can see that I've got several different users listed here. One is me, but I've also got Jim Smith and Kelly Green that I've added to my Azure Active Directory. Now I added these users using the new user menu option here. So I've got a couple of different types of users I can create. One is I can create a new user, which is just creating a user inside of my Azure Active Directory instance. They would have to have an Azure subscription And once I give them access to my Azure Active Directory, I can then control what they can do within my Azure Active Directory. But I also have this concept of inviting an external user. And if I do that, I have to provide the username and an email address, and then their first and last name, and I can give kind of a personal message here. And once I do that, Azure Active Directory will send that person an email, and it'll say, you've been invited to collaborate with this person in Azure Active Directory. And if they accept that, they will then be able to log into that email address using a Microsoft account, and they'll be able to get access into my Azure Active Directory. Now, by default, they can't do anything once they get there unless I give them permission to do that. And we're going to look at how you do that here in just a few minutes. So let's go back to my Azure Active Directory. And the other thing I wanted to show you, because remember, I said you can also use this concept called service principals, which are applications. So I'm going to click on Enterprise Applications right here. Let's add a new application just so I can explain this a little bit better for you. This is the Azure AD gallery of applications. And this has cloud platforms. This also has a long list of different applications that I can add to Azure Active Directory. Now, why would I want to do that? Let's say that I have hired in an intern and I want to give that intern permission to use some of my resources, let's say in Amazon Web Services. I've got some things in Azure, I've got some things in AWS, and I want to give that user permission to use some things in AWS. I can add AWS as an application into my Azure Active Directory. And then when that user logs into the account they use for my Azure Active Directory, it will also allow them to authenticate to Amazon Web Services and manage those resources as well. So they go to Amazon Web Services, they can log in using the same account they use when they log into my Azure Active Directory. And the really cool thing about that is, if that intern leaves my company, I can revoke their access to everything that I've given them access to through Azure Active Directory by simply removing their access in Azure Active Directory. One single operation. So it is very convenient to be able to add these applications inside of Azure Active Directory and allow people then to authenticate to other services using their account that's in my Azure Active Directory. Now, when I first mentioned Azure Active Directory, some of you might have thought that it was a version of Windows Active Directory running in the cloud. But you now know that while Azure Active Directory does share some traits with Windows Active Directory, I mean, after all, they're both identity services, they aren't the same thing. If you're looking for Windows Active Directory in the cloud, you need look no further than Azure Active Directory Domain Services. Now, that's a long name, so let's just call it AD Domain Services. AD Domain Services is a cloud-based version of Windows Active Directory Domain Services, and it uses what are called managed domains and replica sets to provide Active Directory functionality in the cloud. Now, you might be wondering why you need this if you can just use Azure Active Directory instead. You might have a legacy system that doesn't support the modern authentication methods that are used in Azure Active Directory. You might also want to integrate your Azure resources with on-premises Active Directory, or you might need to lift and shift apps that rely on Windows Active Directory domain services to the cloud. In all of these scenarios, Azure AD Domain Services can fulfill your needs. So I mentioned that one reason you might want to use AD Domain Services is because you have a legacy system that doesn't support the modern authentication methods used by Azure Active Directory. So what exactly are those modern authentication methods? Well, the first is called single sign-on, or SSO. SSO allows you to authenticate using the credentials you used when you signed into your operating system. In other words, you boot your computer, you log in, and from then on, you simply use the credentials you logged into the OS with to authenticate to your Azure resources. If you want to authenticate with your on-premises resources using SSO, you can use Azure AD Connect. SSO uses two methods to authenticate users. The first is password hash synchronization. Now, in this method, a user's password is hashed, meaning that a computation converts the password into an encrypted string of characters that's always the same length, regardless of the length of the password. And then that hash is stored in Azure AD. When you need to authenticate, SSO compares the current hash that was created when you logged in with the hash that's stored in Azure AD. And if those two match, Azure AD knows that the passwords must also match, so you're successfully authenticated. The second method SSO can use is called pass-through authentication. This is the method used in Azure AD Connect to authenticate you to on-premises resources. So in this method, SSO hands your credentials to an on-premises pass-through authentication agent, and that agent then sends these credentials to on-premises Active Directory. Once authenticated via Active Directory on-premises, Azure AD Connect passes the authentication back to Azure AD so it can be used to authenticate you to Azure resources. The next authentication method we're going to talk about is multi-factor authentication, or MFA. Now, you're probably familiar with MFA because a lot of the online services you use probably nag you to enable MFA for better security. And from my perspective, that's advice you should definitely take. As its name implies, MFA uses multiple authentication factors. One is something you know, such as a username, password, or a PIN. The next is something you have, such as a mobile device or a security key that provides a time-expired code. And finally, MFA can use something you are. That can be something like a fingerprint, a geometric analysis of your facial structure, or maybe a retina scan. Now, if you combine all three of these components, you have what's called three-factor authentication. If you combine only the first two, you have two-factor authentication. And if you use only one, well, you're no longer using multi-factor authentication. Azure MFA uses two-factor authentication. Now, it could be possible that you use an authentication app with Azure MFA that uses biometrics, but that biometrics authentication is enforced by your device, not Azure. So it's not considered to be an authentication factor used by Azure MFA. MFA is only available in Azure Active Directory premium plans. So if you're using the free version of Azure Active Directory that comes with your Azure subscription, you won't be able to enable MFA. If you do have a premium plan, you can enable MFA in the All Users blade of your directory in the Azure portal. And MFA is enabled on a per user basis. So you can have some users with MFA enabled and others without MFA enabled. You can also enable MFA for guest users, but you have to use a conditional access policy, something we'll talk about shortly. Now, before we go there, let's cover one more authentication method, and that's passwordless authentication. Passwordless, you say. So that sure doesn't sound so secure, does it? Well, in fact, it's quite secure. Passwordless authentication replaces the something you know part of MFA, either the password or PIN, with one of several other security components. The first is Fast Identity Online 2, or FIDO2 security key. FIDO2 uses cryptographic keys that are stored on the user's device, like a mobile phone, or a FIDO security key that's often available as a USB key that contains your encrypted key. Passwordless authentication also supports the Microsoft Authenticator app that's available for both iOS and Android. And when you use the Microsoft Authenticator app, you'll get a notification when you authenticate, and you tap that notification, and the Authenticator app will ask you to enter a number that is displayed on your computer screen. And once you enter that number, you'll then use biometrics or a PIN on your device to complete your authentication. You can also use text message authentication, and when using this method, you'll get a text message on your device with a code that you need to enter on your computer to complete your login. Passwordless can also use a temporary access pass, or a TAP, which is a string of characters that is time limited. So TAP is used for a couple of different scenarios. One is for a user to sign up for one of the other authentication methods. So for example, for a user to configure the Microsoft Authenticator app for passwordless authentication, you can require them to enter a TAP. TAPs are also often used in cases where a user has lost a security device, such as a FIDO2 key or a phone with the Microsoft Authenticator app installed on it. You can also use a certificate to authenticate using passwordless authentication. And finally, you can use Windows Hello for Business, which uses facial biometrics on compatible Windows devices. Earlier, I mentioned conditional access policies. Let's look at exactly what Azure AD Conditional Access is. Azure AD Conditional Access allows you to apply policies that are applied when your resources are accessed. Conditional access uses signals from a user, an application, or another source, and it uses those signals to make decisions about which action it should take. Now, there are a lot of signals that conditional access can use. It might look at who a user is or where they are geographically. It might use the device a user is using or the version of the device's operating system. Or it might use the application that a user is using as a signal. Conditional access can also use Azure AD Identity Protection to identify insecure behavior in real time. And it can do the same with Microsoft Defender for Cloud apps. Conditional access feeds these signals to make a decision on how to handle an access request. So for example, it can block access entirely, but it might also allow access, but only if the user uses multi-factor authentication. Or it might require a certain version of the operating system on a device or a specific kind of device. It might also require that access is via a specific application on a client. These are just some of the decisions that conditional access can make. Using conditional access, administrators can add another level of security when apps or data are accessed. And the fact that business now often allows employees to bring their own device when accessing sensitive resources makes conditional access even more important to a secure environment. We've talked about plenty of authentication mechanisms. Now let's talk about how you can control what a user or resource can do once authenticated. And we'll do that in the context of Azure Role-Based Access Control, or RBAC. RBAC authorizes entities based on roles, and it uses three elements to do so. The first is the security principle. Now, the security principle can be a user, a group, a service principal, remember that's an app, or a managed identity. So a managed identity is a special kind of service principal that represents an Azure resource. The next element is the role definition, often simply just called the role. And the role specifies the permissions that the security principal has. Those permissions are grouped into a role so that you can more easily assign capabilities to a security principal. You can create your own roles with specific permissions, But Azure also includes many predefined roles for specific services, as you'll see in a minute when I demo RBAC for you. The final element is the scope, and that's defined by where the RBAC assignment is made. So for example, if you assign an RBAC role at the resource group level, it applies to all resources in the resource group. Now, scope is important because RBAC rules are additive. In other words, if you assign a role of owner at the resource group level, and then a more restrictive role to a resource that's inside of that resource group, the more restrictive role won't have any effect because of the additive nature of RBAC. So let's go back over to the Azure portal. I'll demo RBAC for you, and that'll give you a better understanding of exactly what this feature is. Okay, so let me set the stage here for you. I've got a web app. We created it here just a few minutes ago, and I want to give someone access to be able to help me with that web app by managing it for me in the Azure portal. I want them to be able to add content to it and all that kind of stuff. And so I need to give them the ability to interact with that web app inside of the Azure portal when they're logged in using their subscription. So I'm going to use RBAC for that. So the first thing I need to do is go into the web app. And here it is right here. So I'm going to just click that. And in the menu for this web app, just as with any other Azure resource, I have this access control IAM menu option. This is how you access RBAC. So I'm going to click that. And now what I want to do is give someone access to this resource. So I am going to click on add, and I'm going to add a role assignment. Now, this is a list of pre-built roles, and some of these are pretty broad. In other words, they apply to just about every Azure resource. So like owner, contributor, reader. But if I scroll down here, all the way at the bottom here, I have this one that's in a category of web, and it's called website contributor. So I'm going to select that for this user. That's a role that's specific to web apps. And then I'm going to click next. So now I have selected the role. I have also specified the scope, right? Because I'm doing this inside of the web app. So that means that the scope for this RBAC assignment is just that web app. So now I need to choose a user that I want to apply this to. And so I'm going to click on Select Members. And I've got this list of users that are in my Azure Active Directory. And in this case, I'm going to give Kelly Green the website contributor role. So I've selected Kelly Green, and I'm going to click Select. And once I do that, you see Kelly Green over here under the list of members. So now all I have to do is click on Review and Assign. Now I can review that. Why would you want to review this? Well, you might have gone through and selected several different users. Maybe you've also added some service principals and things. And so you just want to make sure everything's in order before you assign those RBAC roles. So now I'm going to click Review and Assign, and I see that Kelly Green has now been added. So now when Kelly wants to access this web app and manage it, all Kelly has to do is log in to Azure, and in the portal, Kelly will be able to see this web app as a resource that is manageable. Now let's say that I want to remove Kelly's access. I'm going to go to Role Assignments right here, and then I'm going to scroll all the way down. Here is the website contributor role, and I can see that Kelly Green is here. I'm going to select Kelly from this list, and then I'm going to click Remove right here, and I'll say yes. And now Kelly is no longer a website contributor. So that's RBAC. We've now covered all the concepts you need to know in order to understand our next topic, and that's the concept of zero trust. Zero trust is a security methodology that assumes that every access or behavior in a system is a security breach. Zero trust applies to network endpoints, to data, to apps, to the infrastructure, the computers, network components, and to the network itself. When using zero trust, you use multi-factor authentication to authenticate users, and then you use conditional access to apply policies to secure the environment. Now, that's a key point here because in order for zero trust to work, applications need to be designed for the lowest level of access necessary. In other words, you only give users the level of access to data, apps, networks, and infrastructure that they must have and no more. Now, there's another security philosophy that goes hand in hand with zero trust, and that's the concept of defense in depth. Now, to best understand the concept of defense in depth, consider this castle from the Middle Ages. Castles were built with tough stone to make them difficult to invade. And they also had high walls around the castle that added another layer of security. Now, these high walls can definitely make it harder for invaders to reach the castle, but they don't solve all security problems because invaders can tunnel under the wall and still gain access to the castle. So to help with that problem, moats were built around the castle and filled with water. And in case you're wondering, no, they did not typically have crocodiles in the moats. I actually did look that up to see. So even with all this layered security, it was still possible that invaders might reach the castle. So archers would often be placed around the perimeter as another line of defense. And even inside the castle, soldiers would protect vital areas from invaders. So this layered approach to security describes the concept of defense in depth. In fact, defense in depth is often referred to as the castle doctrine for just that reason. So when you think of defense in depth,
think of castles.
Microsoft Defender for Cloud is a security service that protects Azure resources, but it can also protect on-premises resources and even resources on other clouds. Microsoft Defender for Cloud provides many features to help you with securing your resources. And it also helps with regulatory compliance. And this is especially important these days when regulations related to data access are so complex, with things such as the Health Insurance Portability and Accountability Act, or HIPAA in the United States, and the General Data Protection Regulation, or GDPR, in the European Union. Defender for Cloud also offers workload protections, and a workload means VMs, servers, your applications, your data, all that kind of thing. Defender for Cloud constantly monitors and assesses your security posture, and it looks for problems or vulnerabilities. If it encounters anything that looks weird, it can protect you in real time and activate alerts so you can take additional action. But Defender for Cloud isn't just reactive. It's also proactive, and it provides information and guidance to ensure that you're following best practices for a secure environment. And that makes it easy for you to address security concerns before they become a serious problem. When you deploy new resources to your environment, Defender for Cloud recognizes those new resources and it scans them as well, so you can be sure that you're up to date on the security of your environment, whether that environment is the cloud or on premises.
Welcome to Describe Azure Management and Governance. Here we'll talk about managing costs in Azure. We'll look at what can impact your costs. We'll talk about some tools that Azure provides that can help you predict your costs and make the right decisions about your cloud deployments to keep your costs low. We'll also talk about how you keep an eye on costs after you deploy to the cloud. And we'll cover ways you can classify costs when you get your Azure invoice. We'll also cover tools that help you with governance and compliance. We'll talk about how you can ensure predictable and reliable deployments. And we'll talk about how you can enforce your company policies with minimal effort. We'll talk about how you can also prevent people from modifying or deleting Azure resources. We'll go into detail about managing and deploying Azure resources, including how you can use command line tools that can be scripted for creating and managing resources, and how you can access these tools even from your mobile device or a tablet. We'll talk about how you can extend these management and governance features to your on-premises resources and resources in other clouds. And we'll talk about the underlying component Azure uses to guarantee deployments are predictable and reliable no matter how you perform them. We'll discuss monitoring tools in Azure, including tools that help you monitor your resources, help you keep an eye on problems in Azure itself, and how you can use Azure Monitor to customize your view of the performance and reliability of your Azure resources. The cloud can save you money, but only if you make the right decisions related to your cloud deployments. In this lesson, Describe Cost Management in Azure, we cover the factors that can affect your costs in Azure and how you can minimize costs with those factors in mind. We also cover a couple of different online calculators that Microsoft provides to help you with planning your Azure deployments so you have the most cost savings. We talk about how you can keep an eye on costs after you've deployed to Azure, including seeing a forecast of your month's spending. And we talk about how you can use tags in Azure to more easily categorize spending when you get your Azure invoice.
Way back in Module 1, we talked about the consumption-based model. And one of the things I said is that you should make sure that you aren't paying for more than you need when you're in the cloud. Controlling costs in the cloud might not be as simple as you think, so let's talk about the factors that can impact the cost of your Azure resources. The first factor that can affect costs is meters. Many Azure resources are billed according to meters. Remember when we talked about blob storage tiers, the hot, the cool, and the archive tier? And I told you that you pay for storing data and for access of data. Blob storage actually has 2 meters that can impact costs. You pay for operations like copying files, renaming files, and so on that you perform against storage. And you also pay a per gigabyte charge for data transfer. These are metered charges because you pay based on a measure of your usage. And understanding these meters can help you to control costs. Another example is virtual networks that are peered. If you have virtual networks peered within the same Azure region, you pay several times less per gigabyte of data transfer than you do with virtual networks peered across regions. So understanding these meters can be important. Another factor is how you purchase your resources. If you're using Azure virtual machines, you can save a lot by using Azure reservations, where you commit to usage on a long-term basis. You can also save by running short workloads on Azure Spot VMs. And remember, we looked at a Spot VM checkbox in the portal earlier, and I said I wasn't going to talk about them yet. Now's the time to talk about them. So Spot VMs take advantage of some of Azure's unused capacity. So you can save up to 90% over a pay-as-you-go model if you use spot VMs. You can also save by using what's called hybrid use benefit, and that's where you bring your own license for Windows or for SQL Server. Now, you should be aware that pricing varies per region, and this is because Microsoft's cost for network infrastructure, power, and everything else needed in a data center varies between regions. Even different regions within one country can have different pricing. So planning which region you use for your resources can end up impacting your costs in a big way. The best way for you to ensure you're aware of these things is to check the pricing page for your resources. Each Azure resource type has a pricing page that outlines all the pricing considerations for that particular resource. And these pricing pages can help you a lot with planning your Azure deployments. However, there are other tools that are available to help you with costs, and we'll cover those next. Microsoft offers a couple of different calculators that can help you with pricing. The first is the pricing calculator. The pricing calculator is designed to estimate the cost of Azure resources. You can save your estimates so that you can share them with someone else. Now, remember, these are estimates, not guaranteed cost quotes, but it's a great way to see what-if pricing for Azure resources. You can use this short link to see the pricing calculator for yourself, but let's head over and have a look at it now so you can get a better understanding of just what it offers. This is the pricing calculator. Along the left-hand side, I have a list of different types of Azure resources. And then, depending on which resource type I choose, I'll get a list of different Azure resources that I can add to my estimate. So let's say, for example, I want to find out what would my estimate be if I had a virtual machine with an app service web app and a storage account. The first thing I'll do is add a virtual machine. So now virtual machines have been added to my estimate. Now I'm going to add app service, and I'm going to do the same thing with storage accounts. Now, where did those go when I added them? They're below. I just scroll down here and I can see my estimate. So I'm just going to close these just to give us a cleaner view here. So this is my estimate with virtual machines. And Azure has made some choices for me, but I can choose my own options based upon what my needs are. So for example, maybe West US isn't where I want these. I want them in Central US. And you might have noticed something when I did that. Let me show you. Look down here where this price is, over here in the lower right corner. And I'm going to go back to West US. Notice that the price changes. So as I said earlier, depending on where your resources are deployed, your costs can differ. I can also choose different instance types, so I can choose exactly what I need for my particular workload. Here's my Azure hybrid benefit, which will also save me some money. That's where I bring my own license. So let's go down and look at app service. And remember, we were looking at app service earlier and we looked at the different pricing tiers. This has me right now in basic. Let's say I go to standard. Costs go up a little bit. I scroll down, now I have a storage account. And notice here it's asking me for a couple of things. It's asking me for the tier. I'm going to use standard. So that's that general purpose V2 storage account type. And here's my redundancy options. And remember, we talked about these before. So maybe I want to make this GRS. And now I can go down here and I can specify the number of operations that I anticipate I'm going to have. Now notice right now a lot of these are 0. That's because you don't pay very much for operations against storage. If you're going to end up spending a lot of money on operations, it's because you have a tremendous amount of storage usage. So for an individual, your operations against your storage is going to be really low. I can choose support options. And so now I get an estimated monthly cost, $272.24. Now I can export this, I can save it, or I can share it with someone else if I want to. So that's how I can get an estimate of my Azure expenses using the pricing calculator. The other calculator is called the Total Cost of Ownership, or TCO calculator. This calculator makes it easy to forecast your savings by moving from on-premises to Azure. Now, I also have a short link for the TCO calculator, but let's go over and have a look at it so you can see how it differs from the pricing calculator. And this is the Total Cost of Ownership calculator. So the first thing you have to do with the TCO calculator is define your workloads. So let's add a server workload. And what I do in here is I tell it, is this a Windows or a Linux server, or is it a web app? I specify whether it's a physical server or a virtual machine, the operating system license, the number of servers, the processors. All of these go into the calculation for that particular workload. I can also add additional workloads. So if I have, let's say that these are my VMs, so I'm going to just call this VM. And let's say that I also have a web app, so I'll call this a web app. So now I've got 2 different workloads. I can add additional ones. Maybe I've got some databases. I can add those here. Or maybe I have some storage, so I can add that here. Maybe I've got a network attached storage that I want to add here that I'm using on premises that I need to migrate to the cloud. Then I can specify my networking usage. So let's just say this is going to go to North Europe, just for the sake of an example. You can choose where your network activity is going to go, and I'll click Next. So now I can adjust assumptions. An assumption is something that Azure has assumed based on what I have provided. So I'll scroll down here. You'll see that it has assumed these software assurance coverages. It has assumed nothing for geo-redundant storage. So let's go ahead and turn that on because I want that. It's assumed things like electricity costs, storage costs, the cost of my IT infrastructure. So all of these things I would need to adjust if they're not correct. I have other assumptions down here like hardware costs. Now, this doesn't mean that I added all of these virtual machines. These are just the numbers that Azure will use if I choose a server workload that's configured the way you see it here. So once I've configured all of that, I've adjusted all these assumptions, I'll click Next, and I get this view which tells me how much I'm going to save if I deploy these workloads that I've configured to Azure. And if I scroll down, I get a little more breakdown. So I see how much I'm saving in compute, data center, networking. I get my total on-premises cost breakdown and then my Azure cost breakdown in a nice graph here so I can very easily see where are the differences. Notice I'm paying more for storage in Azure, but everything else is way lower or even maybe non-existent. So again, I get more and more information down here, and just as with the pricing calculator, I can now download this, I can share it, or I can save it. So that's how the total cost of ownership calculator works. Once you purchase your Azure resources, you have some additional tools to help with costs. Azure Cost Management is a powerful tool in the portal for analyzing your costs. You can also create budgets for your Azure spending, and you can even create spend alerts so the people you choose can be alerted if you're getting close to your budget thresholds. Let's go over to the Azure portal and let's have a look at Azure Cost Management in action. All right, so here in the Azure portal, I'm just going to click here in the search, and I'm going to enter cost, and that will give me cost management and billing. You can also click on cost management right here, but I'm going to click here because that takes us to this root level view where we can see things like my subscription, my invoices, my payment methods. So you can look at all of that information here as well and kind of see where you are with your invoice. But you can also click cost management. Now from this home page here, this overview view, you have different options to dig into various areas of cost management. So it's kind of a guided way for you to learn how to use it. You can also just click on different menu options yourself. So if I go to cost analysis, I can see here what my forecast is for usage. So right now I've had an accumulated cost as of right now of 50 cents. Well, I don't have very many Azure resources, so that's not surprising to me. But if I scroll down here, I can see kind of where that usage is coming from. So I'm paying for most of that through Azure App Service and Azure Storage. I can also see the regions where I'm spending this. Now, I've got resources in US Central and US South Central. That's the only place where my resources are. So my breakdown might not be as useful as yours in a real world scenario. Now, as I said, you can also create budgets. And this is where you would go to create a budget. You would just click on add right here. You would specify a name, how often you want your budget to show, and all of the different information that you want included in that budget. And once you've set up a budget, you can then configure cost alerts. So if I go in here and click on add, I can add anomaly alerts so that if my budget is going to be exceeded, people can be notified, just as I said earlier. So cost management gives you a great way to kind of peer into what your usage is so that you can get a better idea of how much money you're spending right now with your Azure resources. Let's talk about tags. Tags might not seem like they're related to billing at first glance, but that is actually one of their most common use cases. Tags are simply name-value pairs that you can apply to any Azure resource, and you can use tags to filter views in the Azure portal. But these tags are also visible on your Azure invoice. So they're a common way for people to separate out the expenses for different categories of spending. So let's head back over to the Azure portal and let's look at tags. Now I've set up some tags already. I'm going to show you how to do that, but I want to show you something before I do that. Let's just have a look at all of my resources here. Now I'm going to add a filter for tags. And notice I have 4 different options here. The only one that was here by default was ms-resource-usage. The others I added. So I'm going to add a filter for department equals marketing. I only have one value for the department tag. If I had multiple, you'd see them here. So we're just going to say department equals marketing, and then I'm going to click apply. And now notice I have only one resource showing. I had 19 before, and that's because this resource, this VM1 resource, has a tag of department that equals marketing. Let's go have a look and see what that looks like. I'm going to click the VM, and let's just get rid of that. Here is the menu option for tags. So notice that there are actually two tags on this VM. One of them is department with a value of marketing. The other one is usage with a value of AZ-900 live training. I can add a new tag by just typing in a new name here. So maybe I want to make this company. Maybe I have several different companies that I have Azure resources for, and I'll call this my company's Gymco. So now I just click apply, and now I have another tag here for Gymco. Now, tags also autocomplete when you're adding them. So let's go back to all of our resources. Let's remove this marketing filter so we can see everything. And we'll go into our storage account. Let's collapse this all resources here. So notice there are no tags right now on this storage account. Let's say that I want to add a department tag to it. If I click right here, I see the tags I've already set up. I can just select it from the list. I could just type a new value, but that just makes it easier for me. And same thing with values. So now I'm seeing a list of values for the department tag based off of what I've already added. So again, I can add my own value, or I can select one that I already have set up. And then I can just click apply. You can also, by the way, remove a tag by clicking the delete button here. And once you do that, you can then click apply. I canceled that. And I can also say, show me all the resources that have this tag value by clicking the little cube. So that gives me a resource list of all of the resources that have that same tag value that I clicked on. So that's tags.
Over time, your cloud consumption is sure to grow. And if you don't take the right steps related to governance and compliance, you can end up with a real mess on your hands. In this lesson, Describe Features and Tools for Governance and Compliance, we talk about how you use Azure blueprints to guarantee deployments that are predictable and that meet all policies of your company. We talk about how you can enforce the policies of your company automatically with minimal hassle, and we cover how to prevent someone from changing or deleting an Azure resource.
Remember when we talked about agility in the cloud? We talked about agility primarily from the context of scaling resources. But another aspect of agility is being able to deploy resources in multiple places in a predictable and a reliable way. And one of the coolest ways to do that in Azure is with a service called Azure Blueprints. Azure Blueprints makes it easy to reuse configurations, policies, and governance of complex deployments in a reusable and easily deployable package. Blueprints can contain many different types of artifacts, including entire resource groups, ARM templates, which we'll cover in Lesson 10, Azure policy assignments, which we'll talk about here in just a minute, and also RBAC role assignments. Once you create a blueprint, it's saved in your subscription or management group, and you can then assign it to easily deploy everything that's in the blueprint. So the workflow of Azure Blueprints is create, publish, and assign. So once you've created the blueprint, you publish it to your subscription or management group, and that makes it available for assignment. You assign a blueprint to a subscription or management group, and when you do that, all the resources in that blueprint are created automatically at that time. Now, you might remember that a management group can only contain other management groups or subscriptions. So if you assign a blueprint to a management group, you'll have to specify the target subscription where those resources will be created. Azure Policy is another service that helps with governance. Azure Policy enables you to define and enforce rules when Azure resources are created and managed. These rules are defined, as you guessed it, as policies. And they could be rules such as requiring that all VMs be a certain size, all resources have to be in a certain region, or maybe that if a particular resource type is deployed, another type of resource must be deployed along with it. There are 6 effects that can be applied in a policy. The first is the append effect, and this adds additional properties to a resource. So just a few minutes ago, we were talking about tags. You could create an Azure policy that automatically adds a tag to specific types of resources. The next effect is audit, and this simply logs a warning if the policy is not complied with. The audit if not exists effect specifies that an additional resource type must exist along with the resource type that's being created or managed. If the additional resource type does not exist, a warning is logged. Now, a little bit related to that is the deploy if not exist effect. That's similar to audit if not exists, but instead of just logging a warning, the additional resource type actually gets deployed automatically. The deny effect, obviously, denies the create or update operation that's being attempted. And finally, the disabled effect simply means the policy is not in effect. It's disabled. We'll close out our discussion of compliance and governance by talking about resource locks, or simply locks. Locks can be used to prevent changes or deletion of Azure resources. And unlike RBAC, which uses roles that a user gets assigned to, locks apply to all users. And probably the easiest way to understand locks, how to use them, how they work, is to have a look at them in the portal. So let's go do that. So you remember a while back when we were looking at RBAC, I said I'm going to have this intern, I'm going to bring this intern in, I'm going to give the intern the ability to manage my web app and help me configure it and things. But I'm a little bit worried since this intern's not really familiar with the Azure portal. I'm afraid that the intern might accidentally delete my web app. And if that happens, I'm in big trouble. So what I want to do is put a lock on the web app that prevents anyone from deleting it. So I'm going to go into the web app right here. And I'm going to scroll down in the list of menu options to the locks option, which is in the settings section of the menu. Just like with RBAC and tags, you're going to have a locks menu option in all of your different Azure resources. So I'm going to go ahead and create a lock. I'm going to click add, and I'm going to call this lock intern protect. You can call it anything you want. Now, it's important to note that there are a couple of different types of locks. A read-only lock prevents you from making any changes to this resource, and that includes deleting it. A delete lock keeps you from deleting the resource, but you can still make changes to it. And so in this case, I want my intern to be able to manage the web app, maybe scale it, make changes to the settings and that kind of thing. I just don't want the thing deleted. So I'm going to use a delete lock. I can add notes if I want to, and then I'll just say OK. So that lock has been added. So now let's go have a look and see what that does. I'm going to go to the overview blade because that gives me the option here to delete. And this is going to attempt to delete the resource. Now look, this is all grayed out. This whole panel here is grayed out. And it tells me this resource has a delete lock that prevents us from deleting. So if I want to delete this, I have to get rid of that lock. Now you might be thinking, well, can't the intern just go delete the lock and then they can delete the web app? They can't because they only have website contributor, and a website contributor cannot delete locks. So that's how you can prevent from that. So that's how locks work.
You've seen a few demos in the Azure portal, but here in Describe Features and Tools for Managing and Deploying Resources, we go into a lot more detail about the Azure portal and how you can customize it to your own liking, including creating dashboard views that show you only what you want to see. We also talk about command line tools for creating and managing Azure resources, tools that you can use on any computer and even on your smartphone or tablet. We talk about how you can extend management and governance features in Azure to your on-premises world and into other clouds. And we cover Azure Resource Manager, how it ensures consistency and predictability, and how you can use templates for consistent deployments to Azure.
The Azure portal is probably the most common tool for creating and managing Azure resources. And as you've seen, the Azure portal is a web-based portal for deploying and managing Azure resources. The portal is fully customizable, personal, and it supports the use of dashboards so you can customize your view based on specific needs. Now, we've already spent a little time in the Azure portal, but let's dig into some of these features that I just mentioned so that you can see how they work. So here's the Azure portal, and this is the way it's going to look by default. If you don't make any changes to the appearance or anything like that, it's going to look like this. But there are lots of different customizations. For example, if I click this little arrow, I get the pop-out menu right here so that I can see the names of these different resource types. And notice that the portal has this concept of favorites. So if I hover over one of these, I'll see that there's a star right here that's been filled in, and I can click that star to make that not a favorite anymore. Notice the star is now hollowed out. So once I make something not a favorite, then it's not going to appear in this favorites list. So if I want to see something that's not in my list of favorites, I can go to all services right here, or I can just simply search for it, which I've done a few times in some of the demos we've looked at. Now I can also customize. If I click the gear icon right here, that gives me the portal menu. And from here, I can change quite a few things. If I go to Appearance and Startup Views, right here is my menu behavior. Right now it's docked, which means this menu over here on the left always appears. Doesn't mean it's always expanded. I can still minimize it and expand it, but it's always going to be visible here. If I put it on flyout, it'll actually hide itself when I'm not using it, and I can move my mouse all the way to the left side of the screen and it'll pop the menu out for me. I can also specify a theme. So if I like something to be blue or light or dark, I can use a high contrast theme. Maybe I have some eyesight difficulty with the theme the way it is, and I can give myself a better contrast so I can see things better. And here's something that's interesting. The startup view is right now at home, but I also have this dashboard option. So let's look at that because that's where things get really interesting. So I've applied that change. Now to see that, I need to go to the home page. And the easiest way to do that really is just click the Microsoft Azure link right here at the top. And now I have this view, which is actually a dashboard. And notice it's called My Dashboard. I also have this other dashboard that I created called VM Dashboard. And this one is specifically showing me some metrics and other things related to my VM1. So you can create any number of dashboards. And if you want to edit a dashboard, click Edit right here. And now I can add additional tiles. Maybe I've already got a clock. So let's go ahead and delete that clock that I just added twice. Let's see what else we have here. I have a security metric. This comes from Azure, so I'll drag and drop that there. 42%, boy, that's not good. So I'll close this, and if I click this little menu here, I can configure the tile settings. I can change the title of it. And then I can also move this to a different location. Now this particular tile is not resizable. Some of them are. This one, for example, notice the little resize indicator down here in the bottom. So I can drag this one and make it larger, depending on what my desire is. And once you've made those changes, just click on Save. And now I have this dashboard. Now the interesting thing here is that your dashboard information is saved to your subscription. So that means if you go to another computer, you're going to have this same dashboard. It doesn't matter where you log into the Azure portal, all of your customization and configuration is going to be stored in your Azure subscription and available to you. And a pretty common use case for using multiple dashboards is maybe you've got some VMs you want to keep an eye on. You've also got some web apps you want to keep an eye on. Maybe you create a dashboard for each one of those and you can just easily switch back and forth and see what you want to look at. And this is real-time data. So you're looking at actual live data from Azure Monitor, something that we'll look at here before too long. And the other interesting thing about that is you can click on this and it'll take you right to where that metric is configured. So you can make changes to this if you want to, and then save that to your dashboard. So highly customizable, very configurable, and a great way for you to see exactly what you want to see in the Azure portal. In addition to the portal, Azure also offers a couple of command line tools for creating and managing your Azure resources. Both of these command line tools are multi-platform, meaning you can use them on Windows, Linux, or Mac OS. Azure PowerShell is a PowerShell commandlet for deploying and managing Azure resources. Azure PowerShell is implemented using the AZ module. And some Azure services have enhanced capabilities by installing extensions to that AZ module. The Azure Command Line Interface, or CLI for short, is an installable command line interface that runs from any console. And like Azure PowerShell, it allows you to deploy and manage resources from a command line. Which tool you use probably depends on your comfort with PowerShell. If you're a PowerShell developer, you're likely going to prefer Azure PowerShell. Many Linux or Mac OS developers are more used to command line shells from Linux, and they're often more comfortable using the Azure CLI. It's really just a preference thing. Now, one of the advantages of having these command line tools is that they can be scripted, so you can perform complex deployments and management operations quickly using scripts. However, there are also some folks out there who simply feel more comfortable at the command line, and these tools are a great choice for them. Now, another command line option for creating and managing resources is Azure Cloud Shell. And Cloud Shell brings both PowerShell and the CLI into the Azure portal and into Azure documentation. Have you ever looked at the documentation and you see these little try it exercises in some of it? Those exercises use Cloud Shell to run Azure command line tools right inside the browser without having to install anything at all. And since Cloud Shell is web-based, it's available on just about any platform. And here's something that's really cool. It's also available on your mobile device, whether that's an Android phone or an iPhone or an iPad or another tablet, using the Azure mobile app. And that means you can run command line operations and scripts from just about anywhere. All right, so let's have a look at these command line tools and how you can use them with your Azure resources. Okay, so I'm here in the Azure portal, and to get to Cloud Shell, just click this button. Looks like a little command prompt up here on the menu bar. And that's going to open up Cloud Shell for me. I'm going to maximize this window just to give us some more real estate. Now, one thing I want to point out before we go any further is that Cloud Shell actually uses a storage account, and it saves information for your Cloud Shell sessions inside that storage account. So remember, I was telling you, you can install modules or extensions onto PowerShell. If you do that from a Cloud Shell session, those modules or extensions will be available to you no matter where you access Cloud Shell, because it's going to store them in Azure Storage. So my Cloud Shell here opened up in PowerShell mode, as you can see right here, but if I drop this down, I can switch that to Bash mode. And so I can use whichever one I'm more comfortable with. I also have a series of buttons here on the top. This button will relaunch Cloud Shell. This will give me some help. The settings button right here allows me to change my text size or the font or reset my user settings. This allows me to upload or download files that are stored in a cloud drive so I can access those from any Cloud Shell session. This button will start a new Cloud Shell session. This button will open an editor where I can edit script files. And I can do that from a web browser. I can do that from my smartphone. I can do that from a tablet using the Azure mobile app. And finally, this button is a web preview. So let me show you. I'm sitting here at a PowerShell prompt. Let's run a couple of commands using the AZ module, Azure PowerShell, and see what we can do with that. So if I run get-az resource and hit enter, that gives me this output, a list of all of my different Azure resources. But I can also modify how that's output. So if I say, for example, get-az resource, all right, and then I'm going to put a pipe character, and I'm going to say format-table. And now I get all of my resources output in a table format. And then I can also specify, for example, which properties I want. So if I go back to this command here that I just entered, I just hit up on my keyboard to get back to the exact same command. I'm going to add to that property, and let's do name and location. So now I'm going to get a table that just has those two properties in it. So you can control pretty well what you're getting from Azure PowerShell. And by the way, format table is just one option. You can also convert the output to different formats. So if I say convert to, -JSON, I get that output in JSON format. Or I could say convert to HTML, for example. Now I get it in HTML format. And of course, you can pipe this output out to a text file if you want to save the output. Now, just so that we can also run some things in the bash shell, so you can kind of see what that looks like, let's go over here and let's test out some CLI commands. Kind of the same thing we did before. The syntax is a little different. So when you're using the command line interface, the Azure CLI, you start with AZ, and then you start with an item type. In this case, it's resource, and then what you want to do with that item. And in this case, it's list. So notice that this one by default gives me JSON. If I want to see that in a table, I use --output and table. And just like you can do with PowerShell, you can also specify the columns that you want, but it's a little bit different with the CLI. You want to add to this command --query, and then in quotes, open bracket, close bracket, period, open curly brace, and then the column name that you want for the first column. So let's just say resource group, and then what you want that to list. I want it to list the resource group. And then name, I want a name column, and that name column should contain the name of the resource. Right? So that'll give me a table that looks like this. Now there's full documentation on Microsoft's website for how you can use both of these tools, CLI and PowerShell. You don't have to know all these commands for AZ-900, but it's kind of cool to monkey around with these and test different commands and see what you can do with them. You've seen a lot of cool features now in Azure that allow you to manage and govern your resources. Azure Arc is a really cool service that extends Azure management and governance capabilities to resources that are outside of Azure. And that means resources that are either on premises or even on another cloud provider. Arc-enabled servers brings Azure management and governance features to physical servers and virtual machines running either Windows or Linux that are on premises or in another cloud. When one of these servers is brought into Azure Arc, it's considered a hybrid machine, and it's assigned an Azure Resource Identifier, so it can even be added to one of your Azure resource groups. Arc-enabled servers works by installing the Azure Connected Machine agent on the machine, and you can install that agent on single machines or a large number of machines easily. Azure Arc also offers a feature called Arc-enabled Kubernetes, and this feature makes it easy to bring Azure management and governance features to your Kubernetes clusters running on premises or in other clouds. In addition, Azure Arc can run some other services on top of Arc-enabled Kubernetes, including Arc-enabled data services, which lets you extend Azure Arc functionality to SQL managed instances and PostgreSQL, which are two popular database services in Azure. And also Azure Application Services, which is an extension that runs on top of Arc-enabled Kubernetes, and it allows you to run Azure Web Apps, Azure Functions, Logic Apps, Azure API Management, and also Azure Event Grid features, either on premises or on another cloud. Now, Azure Arc is a fairly new Azure service, so it's going to be really exciting to see how this technology evolves to bring even more of Azure's functionality to your on-premises environment and to workloads running in other cloud providers. When we were talking about Azure Blueprints a while back, I mentioned ARM templates, and I told you that we would talk about ARM templates in Lesson 10. Well, here we are. But before we go into any information about ARM templates, let's first talk about exactly what ARM is itself. ARM stands for Azure Resource Manager, and it's a system for creating and managing Azure resources. ARM was developed to ensure predictability and repeatability when creating resources. And ARM uses a declarative syntax, which means you don't have to tell ARM how to do something. You only need to tell ARM what to do, and it does it on its own. So how do you tell ARM what to do? Well, you can use one of the many tools available to you for Azure resource creation and management, including the tools that we've already talked about, like the Azure portal, Azure PowerShell, and the command line interface. Or you can use features built into a tool like Visual Studio. However, you can also use an ARM template. ARM templates are JSON files, they're XML files, that declare operations for ARM to complete. And they're a common way to ensure the reliability and predictability of deployments in Azure. So let's have a look at an ARM template so you can see just what I mean by that. So we're back here in the Azure portal. I'm going to click on my virtual machine. And in the menu here on the left, I'm going to scroll down and choose Export Template. And when I click that, I get this view. Let's shrink this down a little bit so we can see a little more of this. This is actually showing me an ARM template that was used to deploy this virtual machine. And so you can see this is in XML format. And you can see that there are different types of resources in here. Here is a type called Microsoft.compute/virtual machines. Pretty clear what that type of resource is. I can even see my tags here. Here are the tags that I added to that virtual machine. And I can scroll down here. I can see here's the OS disk. Here's the storage profile. I can scroll down even further and I can get into things like my network profile, network interfaces. So all of the different resources that were required for my virtual machine are included in the ARM template. And another thing that's interesting here is that you have these parameters. So if you wanted to reuse an ARM template like this, obviously when someone uses it, you would want for them to provide certain values to you rather than having the ARM template specify those. Things like the name of the virtual machine and those types of things. And so you can do that with parameters. Now, most people would not use an ARM template directly out of the portal like this because it's not customized to exactly what they're usually looking for. Most of the time, you'll find that people will build their own ARM templates so they can customize them to do exactly what they need. But by looking at these within the Azure portal, it's a great way for you to get kind of a handle on what ARM templates are and what's contained within them.
Keeping an eye on your deployments is important if you want to avoid availability problems. In this lesson, Describe Monitoring Tools, we talk about how you can proactively monitor your resources with Azure Advisor, including how you can fix problems before they end up impacting you negatively. We discuss how you might know about maintenance events in Azure that might impact your resources or service events that are currently impacting you, and how the power of Azure Monitor enables you to keep your finger on the pulse of your Azure virtual machines and web apps with an extensive tool set for real-time and historical analysis.
Azure Advisor is a service that offers tools to help you ensure high availability of your resources and also efficiency of those resources. Azure Advisors can help you resolve problems that it can identify, and in some cases, it can even fix problems for you. So let's have a look at Azure Advisor in action. Now, I have Azure Advisor as a favorite. So it appears for me on my favorites list right here. If you don't have that, you can just click the search bar up here and search for Advisor. So I'm going to go ahead and click here. And it tells me that it has refreshed my recommendations. And I see a few different categories here in my what's called an advisor score. First of all, I've got an 89% advisor score, which means that I have room for improvement. And so if I look at the score by category over here, I can see clearly that security is what's hurting me. So what are those things going on with security that I ought to be thinking about? Well, there are a couple of ways I can get there. I can click this link right here. I can click this tile right here. I can click on security right here. So any one of those things is going to take me to this view right here, where I can just kind of see what's going on with my security issues. So I see I've got 3 high security problems here. Let's look at one of these things. Virtual machines should encrypt temp disk caches and data flows between compute and storage resources. So I'm going to click on that to see exactly what they're talking about. And I get here a description of what exactly is going on. I get a list of remediation steps. So I can click this link right here. This is what's called a manual remediation, which means in order for me to solve this problem, I have to take some manual steps. Now, there are some cases where Azure Advisor will just have a button here that says fix it, and I click the button and it fixes it for me. This is not one of those things. And I can scroll down further and I can see the resources that are actually affected by this. Let's go back into security and let's have a look and see if we can find one of these things that has an automated remediation. I don't see any here that I know right off the bat have a fix it, so I'm probably not going to be able to show you that. But if, for example, you have an issue where one of the things that I know will sometimes trigger one of these security mechanisms is you're supposed to have a particular agent installed on a VM for security purposes or something like that. If that's an agent that Azure can install for you, you can have it do that automatically for you just by clicking the Fix It button. But in this case, my remediation steps are manual. But even so, if you look here, I get a step-by-step remediation that I can just follow in order to solve this problem. And then once I've solved those problems, I can go back into Azure Advisor and I can look at my advisor score and see how much I've increased that. And you also have, as you see here, a score history. So right now I'm looking monthly at the historical advisor score for my subscription. So you can see over time how your advisor score is trending based upon how you're allocating or how you're deploying your resources and how you're configuring them. In some cases, availability and performance of your Azure resources isn't impacted because of something you did. It might be a problem in Azure itself. And while Microsoft goes to great lengths to ensure the reliability of Azure services, we are talking about computers here. So problems are always going to happen, even if they're rare. Now, if there is a problem within Azure itself, you can use Azure Service Health to get the information you need to understand what's going on. Azure Service Health provides information on Azure service incidents. The information you see in Azure Service Health is automatically scoped to regions where you have Azure resources deployed. And not only does Azure Service Health show you information about unexpected impacts caused by service incidents, it also provides information on any planned maintenance that might impact your Azure resources. Now, the image shown here is an Azure service incident that impacted Azure Application Insights. In the list here, we can see a summary, we can see the regions that were affected, and I also have a root cause analysis tab that I can click, and Microsoft will keep that updated as they investigate. So once they've resolved the problem and they know what caused it, they'll update that with detailed information. Now let's go over to the Azure portal and see if we can find a service incident so that we can look at this in a real-world example. So what we want to do in the portal is we want to go to Service Health. So I'll click on that, and I'll see that right now, each one of these green dots represents an Azure region. And notice they're all green, which means they're all healthy. So what I would like to do is let's look at health history right here, and let's see if we can find something that occurred in the past so we can just have a look at it. I'm going to go back 3 months. And I see I've got a couple of different things here. Here is an issue with Azure Monitor. So I'm going to click that. And what we get here is the same kind of thing that we were looking at earlier in the screenshot. So I see a summary of the impact. I see the start time and the end time. I see the root cause. So this view gives me all the information I need if perhaps I might need to tell someone else in my company about a problem that impacted our service. And I can also download this as a PDF. Now, while this thing is ongoing, let's say that we don't already have a root cause, and this is something that's going on live versus something that happened 2 months ago. I can actually share this link, which is a direct link to this particular incident. And I can also click right here, Track Issue on Mobile, and that gives me a QR code that I can scan on my mobile device, which allows me to track this issue on my mobile device. Another important aspect of keeping your Azure resources healthy is being able to proactively address anything that might be an anomaly. And that means being able to monitor your resources in real time. And it means being able to look at historical data for your resources as well. Azure Monitor is an Azure service that provides that kind of capability. Azure Monitor provides metrics for your Azure virtual machines and web apps. And you can create custom views in Azure Monitor so you can see the information that's most valuable to you. Azure Monitor also offers an extension called Application Insights. Application Insights provides automatic instrumentation for web apps, Azure Functions, and Azure Virtual Machines. And you can even use the Azure Monitor Application Insights agent to provide insights into workloads that are running on your on-premises virtual machines. Now, for historical information, you can use Log Analytics. And Log Analytics is available in the Azure portal, and it provides a powerful environment for analyzing historical data collected by Azure Monitor. Log Analytics uses a powerful query language called Custo Query Language, or KQL, and you can use it to build complex views of performance data. So let's once again head over to the Azure portal, and let's check out some of these features of Azure Monitor. So again, I've got Azure Monitor as a favorite, so I'm going to click it right here. And what I can see here is some different areas where I can get insights. I can get VM insights, container insights on my containers. Application insights is also available here. So what I want to do here is look at some metrics. So I'm going to click on View right here. And I need to set a scope for what I want to look at. I'm going to look at a virtual machine. So let's go into my AZ-900 resource group, and let's choose VM1. I'm going to apply that. And now I've got a list of metrics that apply to a virtual machine. So let's go down, let's see here. Let's choose disk read bytes. And I'm going to change the time to the last 48 hours just so I can see some data here. So I've got a view here that shows me my disk read bytes over this period. Now I can add an additional metric here. If I click Add Metric, I can go in and let's say disk write bytes for the same period. And notice now that I have disk read bytes and disk write bytes, and I can see them in different colors, so I have a very clear view of exactly what I'm looking at. And this right here is a line chart. I can change the chart type, so I can look at an area chart. I can look at a bar chart. So you can look into this exactly the way that you want to see it. Now, one thing that I'll point out here, you don't want to add different metrics here that don't have the same measurement. So for example, it wouldn't make any sense to have something here that is measured, say, in gigabytes alongside something that's measured in a percentage. So you do want to pay attention to that. Now, just as I showed you earlier when we were looking at the Azure portal, if I get a view here that is something interesting to me, I can save it to my dashboard right here. So that's a pretty cool functionality as well. That gives me a live view of whatever I'm looking at here in Azure Monitor. Now, another thing that I talked about was application insights. Let's go back home here and let's go into our web app. And I'm going to click application insights right here. So this is application insights for my web app. I'm going to go ahead and click on the link to view the data for that. Now, I haven't had any activity on this web app. I don't believe. Let's see. I did hit it one time when we were looking at it earlier, but I don't have any activity on that. But if you did have activity on here, you can see that all of these different metrics apply to web applications, failed requests, server response times. So this is another great way of keeping up with what's going on with a web app. And I got all of this automatically. I didn't have to set any settings or configure anything. I just get this for free just by creating a web app. This is something provided to me by Azure Monitor.
Well, we've reached the end of the course. You now have quite a bit of knowledge about Azure under your belt, and you're well on your way to being ready to take the AZ-900 Microsoft Azure Fundamentals exam. In this course, you learned about cloud concepts, including how to define cloud computing. You learned that cloud computing isn't just about networked computers, but it's also about scalability, elasticity, agility, fault tolerance, and more. You learned about the public cloud, the private cloud, and the hybrid cloud. And you learned about how the cloud can help you save money with the consumption-based model. You learned about cloud service types, like infrastructure as a service, platform as a service, and software as a service. You learned the benefits of each, along with the drawbacks. And you learned how your responsibility changes with each. as well as how much flexibility you have with each. You then learned about Azure architecture, starting with regions and region pairs and sovereign regions. You learned why Azure is designed the way it is to help with availability and fault tolerance. You learned about availability zones and how they can ensure fault tolerance. You learned about Azure data centers, and you learned about what Azure resources are and how you can organize them in resource groups and management groups. You learned that Azure Compute refers to resources that use CPU, memory, disk space, and so on. You then learned about compute types like Azure Virtual Machines, containers, and more. You learned about the options available to you for using virtual machines. And you learned about all the resources that are required for virtual machines, including virtual network adapters, virtual networks, IP addresses, and so on. You learned about some of the options you have for hosting applications in Azure, including Azure App Service, Azure Kubernetes Service, and even hosting your application in a virtual machine. You learned about virtual networking and the difference between public and private endpoints. You then learned all about storage in Azure. You learned about different storage services like blob storage, Azure Files, Azure Disks, and more. You learned about the different storage tiers in blob storage, the hot tier, the cool tier, and the archive tier. And you learned how choosing the right tier can save you money. You also learned about redundancy options such as locally redundant storage and zone redundant storage. And you learned how to choose a redundancy option based on your specific needs. You learned about the Azure Storage Account and the different storage account types. And you then learned about ways you can move files into Azure Storage using tools like AZ Copy or Azure Storage Explorer. And you learned how you can use Azure Migrate and Azure Databox to migrate workloads and massive amounts of data to Azure. You learned about Azure Active Directory, the identity service in Azure. You learned about several different authentication methods that Azure Active Directory enables, including multi-factor authentication, passwordless authentication, and single sign-on. You learned how you can enforce conditions for authentication using conditional access. And you learned how you can control access to your Azure resources using role-based access control. You learned about the concepts of zero trust and defense in depth. And you learned how Microsoft Defender for Cloud can increase your security posture in Azure, on premises, or even in other clouds. You learned about how to manage costs in Azure, including those things that might impact your costs, and how to make the best choices to save money. You learned about the pricing calculator and the total cost of ownership calculator, and how each plays a role in estimating Azure costs. You learned about keeping an eye on resources you've already deployed using Azure Cost Management, and you learned how you can use tags in Azure to have a better view of expenses on your Azure resources. You learned about the tools available for managing and creating Azure resources, including the highly customizable Azure portal, Azure PowerShell, and the Azure command line interface. You also learned about Cloud Shell and how it provides command line access even from a smartphone or a tablet. You learned how Azure Arc brings the power of Azure to your on-premises environment or into other clouds. And you learned about the role Azure Resource Manager plays in ensuring consistency and predictability with Azure deployments. You finished the course by learning about how Azure Advisor helps identify problems with Azure resources and can often help you fix those problems, as well as how Azure Service Health and Azure Monitor help you keep an eye on your Azure resources and Azure itself so you can ensure the highest level of availability of your cloud resources. We've covered a lot in this course. I hope you've enjoyed this tour of Azure and that you feel more confident about taking the AZ-900 exam and working with cloud services in Azure. I've certainly enjoyed guiding you through it, and I wish you the best of luck on your exam.